Hi, my dear students. Welcome back to my class. So, today I'm up with the day 13 crash course for the lesson Acids, Bases, and Salts. So, today you're going to understand the entire lesson in one short video, that is Acids, Bases, and Salts. I'm going to explain in today's class. So, you all know that I have started the crash course and the plan is for 20 days. So, almost we are completed 12 days of science crash course, which includes the complete biology and 2 lessons of physics and the 1 lesson from the chemistry. So now today we are continuing with the next lesson of the chemistry part, that is acids, bases, and salts. Okay, so you know that every lesson in chemistry is very important, and the questions are so simple when it comes to application level question or the skill based question. From these particular lessons, they're very easy to write answers, because yesterday we had discussed many things about chemical reactions and equations. I think most of you have got a very good revision related to the frequently asked question or the most expected questions from the lesson chemical reactions and equations in day 12 crash course. I hope students this is true, because many of you were texting me in Instagram saying that ma'am, it was a very good revision for day 12. So I want you to just drop your feedback about day 12 crash course, so that I can continue today with the day 13 crash course. Okay, once again I say very good morning to each and everyone who are present here. Prajwal, Harsha, Anil, Sudeep, okay, Sinchana, many are there. So many students are here today. Yes. Good morning once again to each and everyone who are present in today's class. So we are continuing with acids, bases, and salts lesson in today's class. And this is a very important lesson. You know that every lesson which we speak in the crash course is very important, because I'm going to completely, cover all the topics from each and every individual lesson, so that this is going to definitely help for your examination. Yes. So now, without wasting much time, let me continue today's class. See, when I talk about acids, bases, and salts, students, you want to know what is the nature of acid, what is the nature of base, how can we depict these acids and bases, and what is meant by salts. So this is what one thing which you have to importantly understand. Okay, so if you understand the basic things, it is very easy for you to learn the upcoming concept which is being related to this particular lesson. Yes. So someone is asking, ma'am, I did not read textbook, only by watching your videos can I get good marks? Something, okay, such questions are asking. Yes, Priya, of course, because I'm completely covering each and every topic. You want to look out the lab activities which I'm posting along with this whole entire, whatever I'm posting the video, the crash course. Along with that, you have to take out, the activity based video which I'm posting. So these are the important concepts. So if you just go through each and every concept which I'm explaining here and read the notes which I'm posting in the Telegram, enough, definitely you will get very good marks. And dear students, that the blueprint which I've been posted for the each and every lesson. So if you look at the blueprint for acids, bases, and salts, both in the model question paper as well as in the state level preparatory question paper, they have allotted 6 marks. So 6 marks was allotted for the acids, bases, and salts lesson, both in the model question paper 2022 as well as the state preparatory 2022. That means this particular lesson is very important, and I'll tell you which are the important questions which come in the examination in the day 14 crash course, and I'll tell you how to analyze the when it comes to this particular lesson. Yes. So yes, let me continue, children. Fine. So now let me start with the nature of acids. See, when I talk about the nature of acids, you should know what is meant by acid, what is the nature of acid. See, acids are the substances which are sour in taste. In examination, they may ask you write the difference between acids and bases for 1 mark. Okay, they can ask 1 mark question here. Okay, what is the difference between acids and base? First, you should know what is meant by acid. See, acids are the substances which are sour in taste, and they have a special property that they turn the blue litmus red. So in easy, I can say that if you have a solution in a beaker, okay, and if you add, you don't know what is the solution, okay, if you add acid to it, what happens? If this solution is turning into red color, if this solution is turning into red color, what happened? Then I can say that this solution is acidic in nature. Or you can also do something like this. If you take the solution in the beaker, take the blue color litmus paper, and if this blue litmus paper, when it is dipped in this solution, if it is showing the change in the color, the blue litmus, if it change into red color, then definitely this is said to be a solution which is acidic in nature. This solution is acidic in nature. Dear students, remember, anything which is turning out red in color is having acidic in nature. Understand? So that is one thing you have to importantly note down when we talk about acids. And you must know that they give H plus ions in the aqueous solution. You know what is aqueous solution, because in the yesterday's class I told you what is meant by aqueous solution. Most of the students were answering. Okay, see, when we talk about an aqueous solution, okay, in this aqueous solution, that solution, if the solution contains more H plus ions, then the solution is said to be acidic in nature. I think you're clear with this concept, right? So you have to know what is meant by acid. So what is the nature of the acid? Okay, so I think you all have understood what is meant by aqueous solution. Aqueous solution is nothing but that is a solution in which the solvent will be the water. For example, we have taken a beaker here. So this beaker contains a solution. You know what is solution? Solution is nothing but the solvent plus solute. So let the solute be anything. Solute enadru agili. Let the solute be anything. But the solvent, the one which is going to dissolve that solute, should be the water. Okay. If the solution is, that is the solvent is water, then that kind of solution is called as aqueous solution. So if the aqueous solution contains more H plus ions, that is nothing but that is acidic in nature. It is acidic in nature. I think you are clear with this concept, right? Yes. So what is meant by H plus ions? You must know H plus ions is nothing but the hydrogen ions. H plus hydrogen ions we say. So this is very importantly you want to understand, children. Yes, fine. Now let us go for next topic to understand. See, in examination, they can ask you by giving a group of chemical compounds. They can ask you to identify the strong acids and also the weak bases, or strong acids and weak acids. Or they can ask you write any 2 examples for strong acid. You must know, dear students. See, strong acids. When we talk about strong acids, see, strong acids are hydrochloric acid, sulfuric acid. First and foremost, students, you want to understand the, you want to learn how to write the formulas. You must know the formulas of acid. Note down. Note ಮಾಡ್ಕೊಳ್ಳಿ. You must know. HCl stands for hydrochloric acid. H2SO4 stands for sulfuric acid. HNO3 stands for nitric acid. HNO3 stands for nitric acid. Okay, these are the strong acids. Next, what is meant by weak acid? What are weak acid? What are the examples for weak acid? See, actually strong acid nothing but the acids which contain more, that means the solution which contains the more H plus ions. If there is more H plus ions, then that acid, that solution is considered to be more acidic. I can say this is a strong acid if it is having more H plus ions, and these are having more H plus ions in it. Okay, moving to weak acids, the concentration of H plus ions is less compared to these. Okay, hence this is called as weak acid. Here the concentration in this acids also H plus ions are present. Okay, in this also H plus ions are present, but the concentration of H plus is less. That is why it is called as weak acid. Examples for this is, see, CH3COOH. So let me see which student will answer what is the name of it. I particularly mentioned a formula instead of mentioning the name here. So good morning to everyone who are attending to the class now. Good morning, Asha, Shamit, Navin, Satish, Hashita, Aesthetic Girl, Navin, okay, Atmika, many are there. So some students, those who are joining to the class now, if you are feeling no, the screen is blur. See, in every class I tell you, it is due to the internet issues, this problem you may face. See, once again, I'll tell you, in your YouTube studio, that means not the studio, in YouTube videos, on the screen, if you tap, there is a settings button, click on it, check out the video resolution, put it into the high quality resolution so that you don't face this problem. Okay, fine. So let me see who was answered first. Okay, first correct answer is been given by Ismail, followed by Mallanna Gowder, not Bhumika. Yes. Okay. Okay, fine. So many are giving right answer. As I told you, CH3COOH is nothing but acetic acid. This acetic acid is also having other name called as ethanoic acid. Acetic acid is also having the other name. So that is also been said by Deshad, not Pallavi, Atmika. Many are saying the answers. See, some have the confusion between methanoic and ethanoic. Dear students, one thing you note down. Methanoic is different, ethanoic is different. Meth is having only one carbon, whereas eth is having the 2 carbon atoms in it. Understand? So here we are talking about acetic acid. Acetic acid is nothing but the ethanoic acid. So ethanoic acid, oxalic acid, lactic acid, all these are the examples for weak acid because here the concentration of H plus ions is less. Illenagide andre H plus ion concentration kadime ide. The concentration of H plus ions is less. So you want to note down the difference between strong acid and weak acid. Here concentration of H plus ions is more, here it is less. So these are the examples you want to understand. Next, students, when we talk about, particularly acids, bases and salts lesson, you must know what is the difference between a concentrated acid and a diluted acid. See, concentrated acid is nothing but that is the acid which contain more H plus ions. That means having more of acid, less amount of water, we say. Okay, see, H plus ions are more. Basically what happened, concentrated acid contain less amount of water in it, but more amount of acid in it, which contains more amount of H plus ions in it. Understand? So when I talk about diluted acid, this diluted acid contain more amount of water, but less amount of acid. You might have seen that in your house now, your parents or someone who is taking responsibility of cleaning, see, they dilute the acid to clean the, the toilet walls and all. So when they dilute acid, you might have observed that they take some amount of water, okay, and they add acid to it, okay. So little by little they add acid to it. What happened in this, the amount of water is more and the amount of acid is less because it is a diluted acid, and diluted acid is not so, harsh odor. It is not producing a very harsh odor. Odor is nothing but smell, dear students. Odor andre smell antartha. Concentrated acid is very strong. If we just pour on a surface, the concentrated acid gives more and more, odor, a strong odor it produces that definitely damages our respiratory organs. Okay, so this is the one thing you want to understand when we talk about the dilute acid and also the concentrated acid. Dilute acid contain more amount of water, less amount of acid, whereas the concentrated acid contain more amount of acid but the less amount of water. Yes. Next, we are going to understand the bases. We are done with the acids. Now we are going to understand about the bases. See, what is meant by bases? These are the substances which are bitter in taste and they are soapy when you touch. Okay, as I told you, acids are sour in taste, but bases are bitter in taste. See, one thing you can remember here, B for B, base for bitter. Okay, B for B, base for bitter. So bases are bitter in taste, dear students, and they turn the red litmus solution blue. Means if you take a solution in the beaker, and if you don't know this solution, and when you add a base to it, what happen if this is, for example, if you add a solution to it, what happen if this is turning into the blue, okay, or if it is showing the blue color appearance, so then I can consider it as a basic solution. Or if you take a red litmus paper, okay, and dip into this solution, and if this red litmus paper, when it is turned into blue color, what happen, we can say it as a base. That means the solution is base. Okay, very easy way of checking is taking the litmus paper. Okay, you can check with both red and blue litmus paper. If you take the solution, take the red litmus paper as well as the blue litmus paper. Okay, so if this solution is basic, then the red litmus paper change into blue color. Okay, red litmus paper change into blue color. What about the blue litmus paper? Blue litmus paper does not show any change in the color. It remains as it is. That is the one thing you all have to understand. Yes, very good. So if you are asking the molecular formula of lactic acid, dear student, in examination, we don't ask the molecular formula of lactic acid. So don't, bother about it. I am going to explain you which are the important concepts that will be asked in the examination and that you have to must and should study for the examination point of view. Okay. Yes. Very good. So if you are asking, there is a doubt in heredity and evolution lesson. Yes. Whatever the doubts is there, let us talk at the end of the session. Okay, fine. So let us not interrupt the class in between as I'm continuing with the chemistry part. Okay, I'll definitely clear your doubt at the end of the session. Fine. As I told you, see, this solution, if it is giving the red color litmus paper into blue, this is called as base. And this basic solution contain more amount of OH minus ions. It contain more amount of OH minus ions. See, and at this point of view, you have to understand, children, OH minus is different from OH. Understand? The OH minus ions is one thing which we are writing to represents the base. But OH is nothing but the hydroxide. Hydroxide group does not contain any charge. But, OH minus ions contain a charge here. Understand? OH bere, OH minus ions bere. Artha agtide alva? Yes. Now let us understand the difference between the strong base and weak base. What is meant by strong base? Already, as I told you, strong acid is nothing but it contains more amount of H plus ions. Like that, now strong base is nothing but this contain more amount of OH minus ions. Okay, that means the concentration of OH minus ions is greater in these: sodium hydroxide, potassium hydroxide, calcium hydroxide. Whereas when I say NH4OH, okay, so the concentration of the OH minus ions is less here. Understand? So that is the difference. One thing you have to note down, children, about the strong acids, strong bases, and weak acids and also weak bases. So I think you don't have any doubt in this particular concept now. So can I move ahead? Can I move forward? Okay, now what is the name of this? Who will tell? What is meant by NH4OH? What is meant by NH4OH? Let me see who will answer first. What is meant by NH4OH? I'm waiting for your answer. Okay, I can continue. Okay, first and correct answer is given by Sonia, followed by Anushri, and then Venkatesh and Sharanu. Sharanu has given only the half of the answer, followed by Vani and Gayatri. Many have given the right answers. Toppers tutorials. Okay, many have given. Very good. I appreciate your the involvement in giving the right answers. Very good. So NH4OH is nothing but the ammonium hydroxide. Okay, there are few more, you can take few more examples for weak bases. At this point, dear students, you can take, copper hydroxide you can take, and you can take, zinc hydroxide you can take. They're all weak bases. Okay, because the concentration of OH minus ions is less in it. Okay, Now let me move ahead to understand the next concept. What is meant by alkali? Very important. They will ask for 1 mark in your examination, this definition. Exam only 1 mark ge kedonta chances tumbane irutte. What is meant by alkali? See, alkalis are nothing but they are also the bases. Okay, alkalis are also the bases which are soluble in water. Understand? You can write in exam, the bases which are soluble in water are said to be alkalis. Very, very important concept, my dear students. Exam alli keltare. 1 mark ge definition keltare. Understand? So, the bases which are soluble in water are called as alkalis. Example for it is sodium hydroxide, potassium hydroxide, calcium hydroxide. They are soluble in water. Understand? So, when we drop sodium, potassium, calcium, okay, they are soluble in water. As they are soluble in water, we will call it as, alkalis, because alkalis are the bases which are soluble in the water. Fine. Now let us understand about the salts. We are done with the what is meant by acids, what is meant by bases. Now we have to understand about the concept called salts. What is meant by salts? See, basically the salts are also the compounds. They are formed from the reaction of acids as well as bases. See, in yesterday's class I was telling you, okay, so I was giving you many examples. See, now when I talk about how a salt is formed, a salt is formed when there is a reaction which has been taken place between an acid and a base. Acid plus base gives rise to salt and water. I think you have heard about this particular equation, correct, right? ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ ನಿಮಗೆ ಈ ಈಕ್ವೇಶನ್ ಬಗ್ಗೆ ಗೊತ್ತಿದೆ. What is meant by salt? Salt, how it has been formed? See, salt is formed as a result of the reaction which has been taken place in between the acids and base. Acid ಮತ್ತೆ base combine ಆಗುತ್ತೆ. So, bases combine ಆಗಿ ಏನಾಗುತ್ತೆ? It will produce the salt and also the water. If you are asking, ma'am, there is a doubt in the pH values, ನಿಮ್ಮ ಎಲ್ಲಾ doubts clear ಮಾಡ್ತೀನಿ. Understand? I'm going to clarify all your doubts in this session because I'm completely explaining this lesson. So as it comes to pH section, you can ask and you can listen any question there. Okay, fine. Now we are done with the salts. Yes. Now let us understand what is meant by indicators. Okay, so indicators is nothing but they are the substances, dear students. They are the substances, so they change their color or they change their smell, okay, in different solutions. Okay, when I drop the indicator to different solutions based on the nature of it, okay, so it changes its color, it changes its smell also. Understand? So we will to identify the color, smell of different substances, we use the indicators. So in indicators there are 3 types of indicators, so please note down because these particular concepts are the bridge course for you. If you know the bridge course only, then the actual concept as I go ahead you will understand far better. Okay, so indicators are 3 types, dear students. One is the natural indicator, one more is the synthetic indicator, and the other one is the olfactory indicator. Okay, natural indicators. See, when I say natural, it is nothing but we are getting this from the nature. So these kind of indicators we get from the nature in the plants. Example, litmus, red cabbage, leaves, and also the flowers extract, any kind of turmeric. All these are the one thing which we get from the nature. Understand? Which we directly get from the nature, dear students. You want to understand that. Okay, see, indicators are the one thing which is deciding the nature of the solution. Very importantly, you want to understand, dear students. So they are found in the nature. Understand? So natural indicators are the indicators which are found in the nature. So example, I think you teachers might have taught you in the class, because in my class I have explained my students by extracting the cabbage leaves, red cabbage leaves solution. I have dropped this solution into different to the Coca-Cola and to the sodium hydroxide, to the different solution, to the paste solution and all. So it gives the different colors when we drop these indicators. That decides which is acidic, which is basic. Understand? You want to understand it. Okay, yes. Next, when I talk about synthetic indicators, these synthetic indicators are also the chemical substances. See, because they are manufactured in the lab. Okay, they are prepared in the laboratory. Synthetic indicators are prepared in the laboratory. Anything which is artificially prepared, dear students, we will call it as a synthetic. Adana synthetic anta heli ನಾವು ಕರಿತೀವಿ. Okay, these are the chemical substances. They are, manufactured at the laboratory. Example, you might have seen in your school lab. It is methyl orange and also the phenolphthalein. So we use methyl orange and also the phenolphthalein. See, we take, for example, if we take a test tube, and if in this test tube, if we take, two different solutions, you don't know which is this solution. Okay, if you drop the phenolphthalein to this, what happened? So both of the test tube, if one solution is giving the pink color, is nothing but this solution is basic in nature. If you draw phenolphthalein to other test tube, if there is no change in color, then it is acidic in nature. Very important point. Please note down, this point is a very, very, very important. Yes. See, if you drop the phenolphthalein to this, you don't know which solution is this. Take the solution as A, consider this solution as B. But when you drop the phenolphthalein to both the solutions, if this is giving pink color, then this is basic in nature. If this is not giving any color, then this is acidic in nature. Yake andre phenolphthalein turns pink color in the basic solution and colorless in the acidic solution. So synthetic indicators are also used to identify the nature of the solution. Moving to olfactory. Dear students, olfactory is nothing but something which is related to smell. Okay, so the substances which have a different odor is nothing but smell in acids and bases. So to identify that, we use the olfactory indicators. See, if you take, the clove oil is different in smell, onion is different in smell, vanilla essence is different in smell. We all can identify the nature of it. Okay, so by looking into their odor. Okay, clear. So yesterday's PDF, extremely sorry, I forgot to forward in the telegram. I think Gauri Nagaraj is asking. I immediately send it into the telegram after this class because as I was having a very busy schedule, I could not forward it to you. But very immediately after the class, I will forward. Okay, fine. So I already told you about these examples, children. See, I told you indicators. See, let us now understand how these indicators show their change. Okay, how these indicators are, changing their nature in different things. Litmus. When we take litmus, this is the natural indicator, dear students. See, this litmus, it gives red color in the acidic solution, but it shows the blue color in the basic solution. When we dip the litmus, in the acidic solution, it show red color. In the basic solution, it show blue color. Similarly, red cabbage leaf extract also, if we drop the red cabbage leaves into different solution, if the solution is red, that is red, it is turning out into red color, then the solutions which you have taken is acidic in nature. If it is turning out into green color, then it is basic in nature. Similarly, the flower of hydrangea or the plant products or any kind of things which we are taking, if it is showing these changes, these two things you want to remember, children. These two things frequently, see, you can expect that they can give in examination because red cabbage extract, about red cabbage they have specified. Okay, so you can expect these. Litmus shows red color nature in acidic solution, blue color nature in the basic solution. So this point you remember. Similarly, synthetic indicator, see, phenolphthalein and methyl orange. Okay, phenolphthalein, when it is dropped into acidic solution, it shows colorless. That means it does not show any change in color. The same phenolphthalein, when we drop into a solution which is basic in nature, it turns out into pink color. Similarly, methyl orange, when we drop methyl orange into acidic solution, it turns into red color. The same methyl orange, when it is dropped into basic solution, it turns into yellow color, that is solution. Understand? So these are the one thing you want to understand, dear students. Okay, very, very important. Yes, fine. So now let us understand the olfactory indicators. As I told you, see, onion, vanilla essence, clove oil, all these are examples for olfactory indicators. So when we drop an acid, okay, acid to the onion, what happened? Characteristic is it produces the smell. Okay, so when we drop the base on it, it does not produce any kind of smell. Similarly, vanilla essence, okay, so when we drop the acid to it, it retains back its smell. but when we drop base on it, it does not show any kind of smell. Clove oil also retain its smell, but the base, when it is dropped on it, it loses its smell. Okay, clove oil will loses its smell. Okay, fine, very good. So now we are understood the basic thing. Now we are going to understand the most important concept of today's lesson, that is children actual concept. I'm starting now. Till now you have understand about all the basic things which you wanted to understand to know the acids, bases and salts lesson. Because anything which we are starting, we should not start directly, because you don't know the background of it. Okay, so you have to understand. See, as I told you that indicators, you should have an idea about indicators. Suppose if in examination, if they ask a skill based question related to indicator by giving examples, because it is in the textbook. Okay, if it is not in the textbook, we could have skipped. It is in the textbook. Okay, so we can expect this. And if you are asking about physics program, see, physics children, as they have completely explained in Kannada, I took some time to translate into English. It has been translated, so soon I will post. Please stay tuned. Don't feel bad, because the terminology is very difficult and it was very different in Kannada version. As I teach in English, so it took for me a bit of time to translate it. Okay, definitely I will post it soon. Fine. So now we are going to understand, as I told you, the important concept of these lesson. Okay, yes. Now we are starting with the chemical properties of the acids and bases. So till now you have understood the properties, the basic natures of it. Yes, chemical properties of acids and bases. See, when I talk about the chemical properties, you have to know the reaction of metals with both the acids as well as bases. That means how these metals will react with the acids and also the bases. Dear students, see, I have mentioned here in the equation form. See, when you are reading or when you are making the notes for yourself, please make the notes in such a way that should be very easy for you to read. Only then you show interest. ಯಾವುದೇ ಆಗಲಿ ನಮಗೆ ಈಸಿ ಅನ್ನೋದಾದ್ರೆ ಏನಾಗುತ್ತೆ, we will show interest towards it very fastly. Okay, so you have to make a note in such a way that when you're reading it should be easy. See, reaction of metal with an acid. See, acid plus metal gives rise to salt and also hydrogen gas, a very important concept. Okay, when we drop a metal piece into a acid, this metal will react with the acid, and as a result of it, dear students, it produces the salt, and very importantly, it produces the hydrogen gas. They can ask you in the examination, name the gas produced when an acid reacts with metal, or when a metal reacts with an acid. They can ask you like this, name the gas produced when a metal reacts with acid. Which gas is produced? Yes, it is none other than hydrogen gas. How do you check whether the gas produced is hydrogen or not? How do you check? Take a incense stick near the gas where it is released. You will hear a popping sound. So ಇದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆದಂತ ಲ್ಯಾಬ್ ಆಕ್ಟಿವಿಟಿನ ನಾನು ಪರ್ಫಾರ್ಮ್ ಮಾಡಿದೀನಿ. ಡ್ರಾಪಿಂಗ್ ದ ಜಿಂಕ್ ಇನ್ ದ ಡೈಲ್ಯೂಟ್ ಹೈಡ್ರೋಕ್ಲೋರಿಕ್ ಆಸಿಡ್ ಲ್ಯಾಬ್ ಆಕ್ಟಿವಿಟಿ ನಾನು ಮಾಡಿದೀನಿ. I think those who are new to this channel today, those who are watching the channel for the very first time, check out the playlist after the live admele. Okay, after the live, once the live is completed, please check out the playlist so that you will get a video of lab activities. There you will find this video called reaction of zinc with the dilute hydrochloric acid. See, it produces the pop sound, children. Very clearly you can hear in my video, I have shown it. Okay, so when a metal reacts with acid, it produces a salt and hydrogen gas. Here is an example. So this statement you have to remember. If it is it may be any metal. Okay, so here one example is given, that is zinc is combining with hydrochloric acid to produce zinc chloride. So so okay, before explaining this, tell me now, children, which type of reaction is this? Because yesterday you all have understood chemical reactions and equations, right? You all have understood chemical reactions and equations lesson, right? So which this is an example for which kind of chemical reaction? Okay, I'm waiting that who will. Yes, handwritten notes is already shared. I have already shared in Telegram. Yes, Tulsi has given the first and very correct answer, followed by Vishwajit, and also Sharanu, Monisha, Shamit is, I think, still confusion about this. Please watch the crash course. So Kirtana, Harshita, yes, Manjunath, Manjula, Atmika, Vani, Netra, many have given correct answer. Sonia has still confusion about the particular topic. Please watch the crash course, yesterday's crash course. You will get the clear information. Okay, yes. Dear students, see, I told you, if you look at this, okay, so here zinc is, a more reactive metal which displaces the, hydrogen here. Understand? So what happened when a metal is dropped into hydrochloric acid? What happened? It displaces the hydrogen gas here. It displaces the hydrogen gas. This is an example for displacement reaction. And as a result of it, what happens? Zinc is combining with the chlorine to form the zinc chloride. Zinc is combining with the chlorine to form the zinc chloride. And this zinc chloride is a salt, dear students. And hydrogen gas is released or liberated, we can say. Okay, next. So I think you're clear with this. You can take any example at this moment. Okay, any metal, when it is, dropped into an acid, it produces salt and hydrogen gas. Except when it is, when we talk about nitric acid. So nitric acid ಬಗ್ಗೆ ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೀನಿ, I'll come up. Okay, see, nitric acid ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, when you drop the metal into nitric acid, what happened? As nitric acid is a strong oxidizing agent. Nitric acid is a strong oxidizing agent. It does not produces the hydrogen gas. You want to remember, dear students, ಈ ಪಾಯಿಂಟ್ ಇದೆಲ್ಲ ನಾನು ಹೇಳ್ತಾ ಇರೋದು ಬಹಳನೇ ಇಂಪಾರ್ಟೆಂಟ್, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. See, most of the metals react with the acid. It produces the salt and hydrogen gas. But when we drop the metal to the nitric acid, so-called HNO3, as the nitric acid is the strong oxidizing agent, as it is the strong oxidizing agent, it does not produce the hydrogen gas, dear students. You want to note down. Very important topic this is. Yes. So now let us talk about the bases. See, what happens when a metal reacts with the base? See, when the metals react with the base, it also produces the salt and hydrogen gas. Okay, when the metal reacts with the base, it also produces the salt plus hydrogen gas. But remember, not all the metals are reacting with the base. Only few metals will react with the base. So in exam, they ask you, if they ask only this example, they will ask. Only which is in textbook, they will ask this year. That is 100% guarantee I am giving. Okay, because as we have discussed with the, some of the resource persons, and, we have an idea that what might come to the exam. So apart from the textbook, you don't get anything, dear students. Okay, see, not all the bases will react with the, metal. Only few bases will react with the metal. Here in textbook, they have given the base which is reacting with the metal is here zinc. Okay, zinc is reacting with the sodium hydroxide. As a result of it, what happened? It is also, making the hydrogen gas to liberate, and also it forms the sodium zincate salt. Sodium zincate, Na2ZnO2. Please note down the formula. You have to remember the name of it. Okay, sodium zincate, Na2ZnO2. This the salt is formed when a base react with metal. I am stressing on each and every concept, dear students. So it is easy for you to remember. Okay, why I'm stressing on the concept? Because it's a final revision which I am doing for every lesson. Okay, so in one shot videos, I am doing the final revision for every lesson, so that you can save the time. You can save the time in, putting your effort on the same lesson again and again. Yes. See, the base which is reacting on the, metal here is sodium hydroxide. When the zinc is reacting with sodium hydroxide, it forms the sodium zincate. And here also hydrogen gas is liberated. Yes, very good. Now, see, as I told you, this point is very important. See, hydrogen gas is, children, hydrogen gas is released when, when a metal react with an acid. Okay, and hydrogen gas released can be tested by bringing the burning candle, or you can also take an incense stick, or you can take a matchstick, burning matchstick you can take. Okay, so if you take the matchstick, you will get the pop sound, definitely. Okay, immediately the flame turn off, and by releasing a large pop sound. Understand? Yes, fine. I think you're clear with this concept, dear students. So shall I move ahead? So what you understood, right? How does the metal react with an acid? Metal react with the base. This is the one thing you have to remember. Okay, metal react with acid to produce salt and hydrogen gas. Metal react with base also produces salt and hydrogen gas. Few examples you want to remember. Okay, fine. If you are clear with this concept, I will move ahead, children. Shall I go ahead? Yes. Fine. Okay. So now, let me explain you the next concept, that is the reaction of metal carbonates and metal hydrogen carbonate. See, I am telling you, dear students, this concept is very, very, very important because 3 marks question is asked many times from this particular concept. Many times is, 3 marks question is asked from this particular point. Okay, yes. So I'll tell you what kind of questions will come from this particular point also. See, what happens when a metal carbonate is nothing but a carbonate group, that is nothing but CO3 group. Carbonate is nothing but CO3. So this CO3 is attached to a metal. Okay, hence it is called as metal carbonate. A metal hydrogen carbonate. Hydrogen carbonate is nothing but HCO3 group is attached to a metal. Okay, so when a metal carbonate or metal hydrogen carbonate react with the acid, what is the result you obtain? You want to understand. Very important. It is given in page number 20 in your textbook. Very important topic. See, when a metal carbonate is reacted with the acid, okay, it may be any diluted acid. Here we have taken hydrochloric acid. Okay, when a metal carbonate is reacted with the acid, it produces the salt, dear student. Along with this particular gas, you have to remember, 100% you have to remember, carbon dioxide gas is released along with the water. See, this statement nenpitkolli. Remember this statement. The reaction of metal carbonates with an acid. What does it give? Acid combined with metal carbonate to produce the salt, carbon dioxide, water. Remember this product. Salt, carbonate, carbon dioxide and water. Very important. It produces salt, carbon dioxide and water. And the gas which is been released here, when it is passed into lime water, the lime water turns milky white. And I told you in the yesterday's class, as I told you, I have informed you that carbonates is present means it definitely going to release the carbon dioxide gas. If nitrates are present, it releases the nitrogen gas. I told you, if hydrates are there, what happens? Then it releases the hydrogen gas. Very important. I told you in the yesterday's class. Fine. Okay. Once again, let me repeat this concept. See, when an acid react with the metal carbonate, in the exam they can ask you skill based or application level questions from this part for 3 marks, children. See, public exam ಅಲ್ಲಿ 3 times ಕೇಳಿದ್ದಾರೆ ಈ particular topic na 3 times ಕೇಳಿದ್ದಾರೆ. Very important. Yes. See, when an acid is reacting with the metal carbonate, once again I repeat, it produces the salt, carbon dioxide gas and water. So here is an example. So whenever a metal carbonate or metal hydrogen carbonate, both, see, whenever a metal carbonate or metal hydrogen carbonate, these both also, whenever it react with acid, the product remains same. The product is same. There is no change. Example you can look at here. See, acid is combining with here sodium carbonate, that is Na2CO3. You can check out here. Sodium carbonate, and it gives rise to salt, that is sodium chloride. Along with this, we are getting carbon dioxide gas and also the water. Similarly, when the same diluted hydrochloric acid, when it is reacting with the sodium hydrogen carbonate, metal hydrogen carbonate, understand? Sodium hydrogen carbonate, it also produces the same product. There is no change in the product. Okay, there is no change in the product. Please, okay, please, no, everyone, I request you to please focus on the concepts. Please focus on the concepts. Okay, yes. See, when an acid is reacting with the metal carbonate or metal hydrogen carbonate, the product remains same, children. That is sodium chloride, a salt, carbon dioxide gas and water is been released. Very important. Next, the same, okay, when the metal carbonate or metal hydrogen carbonate, when it is reacting with the base, there is no reaction. No reaction takes place. Okay, when a metal carbonate or metal hydrogen carbonate, when it is reacting with the base, there is no change in the reaction. There is no product formed. Okay, yes. See, as I told you, see now what happened? The carbon dioxide gas is released, right? So the released carbon dioxide gas, when it is passed, see, the carbon dioxide gas is released. You can check, ನೀವು ಚೆಕ್ ಮಾಡಬಹುದು ಇದು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್ ಏನಾ ಅಂತ ಚೆಕ್ ಮಾಡಬಹುದು. You can check whether the gas released this carbon dioxide only by following process, because we have already checked the test for hydrogen gas. See, to check the hydrogen gas, we have taken burning, matchstick near the mouth of the reaction where it took place. What happened? It releases the pop sound. So pop sound says that the released gas is the hydrogen. Similarly, we can also check, illina kuda ನಾವು ಚೆಕ್ ಮಾಡಬಹುದು, the released gas is carbon dioxide ಏನೇ ಅಂತ ನಾವು ಚೆಕ್ ಮಾಡಬಹುದು. So ಹೇಗೆ ಚೆಕ್ ಮಾಡ್ತೀರಾ? So take that is pass the released carbon dioxide into the lime water. Lime water formula is calcium hydroxide. Okay, when you pass this carbon dioxide gas which is released in this reaction into the lime water, it will turn out into calcium carbonate. Okay, what is meant by calcium carbonate? In yesterday's class I have explained about calcium carbonate, calcium hydroxide, calcium oxide, all these things I have explained. Calcium carbonate is nothing but the one of the product which is producing the shiny nature, white color shiny nature. Understand? So you must know, dear students. Okay, so here when carbon dioxide is passed to calcium hydroxide, that is the lime water, it gives calcium carbonate. Along with this, water is also produced. Very good. So many are answering. Very good. I appreciate your involvement, dear students. I appreciate your involvement, because you have to answer when I am explaining. That is how you are realizing the concept and understanding the concept. Yes. So this particular question, definitely see, ಇದರ ಬೇಸಿಸ್ ಆ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ ನಿಮ್ಗೆ. ನಾನು ಕ್ರಾಶ್ ಕೋರ್ಸ್ ಅಲ್ಲಿ ಹೇಳ್ತೀನಿ ಯಾವ ವೆರೈಟಿ ಆಫ್ ಕ್ವಶನ್ ಅನ್ನ ಕೇಳ್ತಾರೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಅಂತ. ಎಸ್, ಈಗ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್ ಅನ್ನ ನಾವು ಪಾಸ್ ಮಾಡಿದಾಗ, ವೆನ್ ವಿ ಪಾಸ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಗ್ಯಾಸ್ ಟು ಲೈಮ್ ವಾಟರ್, ವಿ ಗಾಟ್ ಕ್ಯಾಲ್ಸಿಯಂ ಕಾರ್ಬೋನೇಟ್. But the same carbon dioxide gas, when you pass in an excess amount, that means after the formation of calcium carbonate, if you are still passing the carbon dioxide gas, what happens? This particular calcium carbonate will fade. As a result of it, it forms the calcium hydrogen carbonate. So now what happened? So the white color, which is appeared in the lime water, that means I told you lime water turns milky white. So now what happened? As you pass more amount of carbon dioxide to it, this will fade out. The color of the solution will fade out. Color of the solution will fade out, dear students. Yes. Yes, if you are asking a discussion group in Telegram, sure, definitely I'll do it today. Okay. Yes. But you should not, misuse the children, because you chat yourself. That is the reason I have not made a discussion group. Last year it was there actually. Okay, so if you're using the group for healthy purpose, definitely I'm going to start a discussion group so that you can ask any of your doubts there. Yes, fine. So this concept is very important. From page number 20 to 21 continuation. See, very quickly I will recall this topic. See, please listen, understand. 3 marks you will get from this particular concept. 3 marks. Okay, fine. Because in many question paper they have asked it. So we are talking about the reaction of metal carbonates or metal hydrogen carbonates with the acids. Dear students, see, when a metal carbonate or metal hydrogen carbonate, when it is dropped into acid or when it is reacting with the acid, it produces salt, carbon dioxide and water. Very important. Okay, and when this produced gas is being passed to the lime water, why are we passing? We are passing this carbon dioxide gas to check whether it is carbon dioxide or not. So when we pass the carbon dioxide gas to lime water, what happened? It forms the calcium carbonate by turning the solution into, white. Lime water turn milky white in color. Okay, as a result of the presence of carbon dioxide. When this carbon dioxide is passed in excess amount to the same calcium carbonate, what happened? This lime water, that is, which is milky white in color, will fade out by forming calcium hydrogen carbonate. I think you are clear with this doubt. Yes, you are clear with this doubt. Fine. So shall I move ahead, children? So you have to understand that milkiness, that means milky white color, disappears. Fine. So you are clear with this concept, means I will move ahead. Yes. So the next concept is the reaction of acids and bases with each other We will call this reaction as the neutralization reaction. We will call this reaction as the neutralization reaction. Okay, fine. See, reaction of acids and base with each other is called as neutralization reaction. What exactly we have to do here? See, neutralization reaction is a reaction where it happens or it takes place between acid and also base. Okay, when acid and base combine, what happens? It produces salt and water. So this particular type of reaction, we will call it as neutralization reaction. This particular type of reaction, we will call it as neutralization reaction, dear students. So you have to remember what is meant by neutralization reaction. It is a reaction which takes place between a acid and base. And what is the product it forms? It forms the product called salt. Sodium chloride is a salt and also water is formed. Clear? I think you are clear with this particular concept. Shall I move ahead to explain next concept? Yes. Now, so the next concept here we are looking at here is strong acid plus weak base. What is strong acid? What is weak base? Strong acid is nothing but the acid which contain more amount of H plus ions. Weak base is nothing but the base which is contain less amount of OH minus ions. Ashte. Nimge already strong acid andre enu, strong base andre enu anta helidini. Venkatesh, I'll talk to you at the end of the session about the Zen. Okay. At the end of the session, I will tell about Zen. Okay. Yes. See, strong acid plus weak base. As it, anything which is in strong acid, we have to remember that it is rich in more H plus ions. If it is strong base, it is more having more amount of OH minus ions. If it is weak, just reverse, children. If it is a weak acid, that is nothing but it is having less amount of H plus ions. If it is a weak base, it is nothing but it is having less amount of OH minus ions. See, when a strong acid and weak base combine, it will produce the acidic salt. It produces the acid. See, how to remember, ma'am, heng ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಇದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಯಾವುದು ಸ್ಟ್ರಾಂಗ್ ಇದೆಯೋ ಅದೇ ಬರುತ್ತೆ. ಯಾವ್ದು ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಇಲ್ಲಿ? ಸ್ಟ್ರಾಂಗ್ ಆಗಿರೋದು ಆಸಿಡ್. ಸೊ ಆಸಿಡಿಕ್ ಸಾಲ್ಟೇ ಬರುತ್ತೆ. ವೀಕ್ ಆಸಿಡ್ ಪ್ಲಸ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್. ಯಾವ್ದು ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಇಲ್ಲಿ? ಬೇಸ್. ಸೊ ಬೇಸಿಕ್ ಸಾಲ್ಟ್ ಬರುತ್ತೆ. ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಪ್ಲಸ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಎರಡೂ ಸ್ಟ್ರಾಂಗ್ ಇದೆ. ಸೊ ಇಟ್ ಇಸ್ ನ್ಯೂಟ್ರಲ್. ವೀಕ್ ಆಸಿಡ್ ಪ್ಲಸ್ ವೀಕ್ ಬೇಸ್ ಎರಡೂ ಕೂಡ ವೀಕ್ ಇದ್ರೆ ಅದು ಕೂಡ ನ್ಯೂಟ್ರಲ್. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಈಸಿಯಾಗಿ ನೆನ್ಪಿಟ್ಕೊಳ್ಬಹುದು. ಓಕೆನಾ? ಸೊ ಈಸಿಯಾಗಿ ನೀವು ನೆನ್ಪಿಟ್ಕೊಳ್ಬಹುದು. ಐ ಥಿಂಕ್ ಯು ಆರ್ ಕ್ಲಿಯರ್ ವಿತ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್. Now let us understand the reaction of metal oxides with acids. So ನೋಡಿ, ಇದು ಕೂಡ ಇಲ್ಲಿ activity based question ಕೇಳ್ತಾರೆ. Actually this is related to activity 2.7. Reaction of metallic oxides with bases. ಇದು activity 2.7 ಒಂದು activity based concept. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, you have to understand. See, metallic oxides are basic in nature ಅಂತ ಹೇಳ್ತೀವಿ. We say metallic oxides are basic in nature. How can we say metallic oxides are basic in nature? See, for this I will give you one example. So let us take small amount of copper oxide in a beaker. See, if we take copper oxide is represented by CuO. If we take copper oxide in a beaker, okay, and if we add the dilute hydrochloric acid, let us add now dilute hydrochloric acid, which is nothing but HCl. Okay, so I have taken the copper oxide. So what is here copper oxide? Copper oxide is a metal oxide. So that is why we say metallic oxide. What are we talking here? We are talking about metallic oxides behavior with the acid. Reaction with metallic oxide. See, I have taken a metallic oxide, which is a copper oxide. So when this copper oxide is reacting with the acid, what is the product form? See, this copper will combine with the chlorine. Hydrogen will combine with the oxygen. As a result of it, what happened? Copper chloride, a salt is formed. Copper chloride, a salt is formed along with the water. Copper chloride salt ಜೊತೆಗೆ water form ಆಗುತ್ತೆ. Understand? And ಈ copper chloride ಏನಿದೆ, this copper chloride is basic in nature. ಇನ್ನೂ ಈಸಿ ಆದ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ. I will give you still more easier example. ಈ ಆಕ್ಟಿವಿಟಿನ ನಾನು ಮಾಡಿದ್ದೀನಿ. See, you can check in the playlist in the lab activity. So let us take now, okay, let us take magnesium. Let us take magnesium. So when we take magnesium and burn in the presence of oxygen, so what is the product we get, children? So let me see who will answer first for this question. What is the product we get when we burn magnesium in the oxygen? What is the product you get? when we burn magnesium in the oxygen, what is the product you get? Okay, let me see. Yes, what is, yes, very good. First answer is given by Manjula, followed by Flex Gaming, and Kirtana, Vishwajit, Anushri, Gauri has given. Fine. So magnesium oxide. So magnesium, when it is burned in the presence of oxygen, we get magnesium oxide. So this magnesium oxide, now it is a metal oxide. So let us take this magnesium oxide. This is actually now ash. Magnesium na burn ಮಾಡಿದಾಗ magnesium oxide ಏನು ಬರುತ್ತೆ, ಇದು ash ಆಗಿರುತ್ತೆ. So ಈ magnesium oxide ಗೆ, okay, when we add some amount of water, ಈಗ ನಾವು magnesium oxide ಗೆ ಏನು ಮಾಡೋಣ, water na add ಮಾಡೋಣ. When we add the water to magnesium oxide, we get the product magnesium hydroxide. We get the product magnesium hydroxide, MgOH2. We get the product magnesium hydroxide. So ಏನಕ್ಕೋಸ್ಕರ ಇದನ್ನ ಬರಿತಾ ಇದೀನಿ ಅಂದ್ರೆ, we have to justify. Metallic oxides are basic ಅಂತ ಹೇಳ್ತಾ ಇದೀವಲ್ಲ, we have to justify. See, the magnesium oxide now which is been formed here, okay. So when we take the red litmus paper and dip in this red litmus paper will change its color to blue. And when we take the blue litmus paper and dip in this, okay, the blue litmus paper does not change its color. It remains as it is. We can say that the metallic oxides are basic in nature, because see, the metallic oxide now I have mixed it with the water. And when I mix it with the water, we got magnesium hydroxide. And the magnesium hydroxide is base. And this base is basic in nature. Similarly, okay, copper chloride, that is, which I told you. Just now I told you about copper chloride. So here they have given calcium chloride. I told about copper chloride. Copper chloride is also a basic in nature. Okay, basically metallic oxides are basic in nature. You have to remember, dear students. So ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಕ್ಟಿವಿಟಿ ನಾನು ಮಾಡಿದ್ದೀನಿ, ಬೇಕಂದ್ರೆ ನಿಮಗೆ ನಾನು ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ, ನಾಟ್ ಇನ್ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸ್, ನಿಮ್ ಚಾಟ್ ಕಮೆಂಟ್ ಏರಿಯಾದಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡ್ತೀನಿ ಒನ್ಸ್ ದ ಕ್ಲಾಸ್ ಗೆಟ್ ಓವರ್. ಓಕೆನಾ? ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ಮೆಟಾಲಿಕ್ ಆಕ್ಸೈಡ್ಸ್ ಆರ್ ಬೇಸಿಕ್ ಇನ್ ನೇಚರ್. ಓಕೆ, so example you can write calcium oxide, magnesium oxide, they're all basic in nature. Okay, fine. So now let us talk about the reaction of non-metallic oxides with the bases. See, non-metallic oxides, when it is reacting with the bases, it also produces salt and hydrogen gas. Very important. Reaction of non-metallic oxides with the bases we are talking. Understand? Here, so here we can take any kind of non-metallic oxide. Let us take carbon dioxide. Carbon dioxide. Carbon is a non-metal, and when it is combining with oxygen, we say it as non-metallic oxide. Okay, I think you got a clarity why we are taking this example. Okay, carbon is a non-metal. You know what is, which is a metal, which is non-metal. Okay, carbon is a non-metal. So and oxygen, it is combining with the oxygen, so it is a non-metallic oxide. So when this non-metallic oxide, when it is combining with the base, that is calcium hydroxide, I got a salt, calcium carbonate salt we get, and we also got the water. Okay, so for this particular thing, I can give you a best example, children. Let us take sulfur. Let us take sulfur. Everybody is aware about sulfur, right? So sulfur is a non-metal. Okay, sulfur is a non-metal. So if we take a sulfur in the spatula, ಒಂದು spatula ಅಂತ ಹೇಳ್ತೀವಿ ನಾವು ಸೈನ್ಸ್ ಅಲ್ಲಿ, so spoon ರೀತಿ ಇರುತ್ತೆ ಇದು. If we take the sulfur in the spatula and burn it, okay, so ನಾವೇನ್ ಮಾಡೋಣ, ಈ sulfur ನ burn ಮಾಡೋಣ. Let us burn this, okay, by keeping under the Bunsen burner. So burn ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, this sulfur releases the fume, that is gases. Gas release ಮಾಡುತ್ತೆ. ರಿಲೀಸ್ ಆಗುವಂತ ಗ್ಯಾಸ್ ಅನ್ನ ನಾವು ಏನ್ ಮಾಡೋಣ, ಒಂದು ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ನಲ್ಲಿ ಕಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಲೆಟ್ ಅಸ್ ಕಲೆಕ್ಟ್ ಇನ್ ದ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್. ಸೊ ನೌ ವಿ ಹ್ಯಾವ್ ಬರ್ನ್ ಸಲ್ಫರ್ ಅಂಡ್ ವಿ ರಿಸೀವ್ಡ್ ದ ಗ್ಯಾಸ್ ವಿಚ್ ಇಸ್ ಬೀನ್ ರಿಲೀಸ್ ಬೈ ದ ಬರ್ನ್ ಸಲ್ಫರ್. ಸೊ ದ ಗ್ಯಾಸ್ ವಿಚ್ ಇಸ್ ಬೀನ್ ಟೇಕನ್ ಆರ್ ಕಲೆಕ್ಟೆಡ್ ಇನ್ ದಿ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್. ಈಗ ನಾವೇನ್ ಮಾಡೋಣ, ಈ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ಗೆ ಲೆಟ್ ಅಸ್ ನಾವು ಆಡ್ ಫ್ಯೂ ಡ್ರಾಪ್ಸ್ ಆಫ್ ವಾಟರ್. ಸೊ ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಇದು ನಮಗೆ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. Now take the litmus paper. Take both the red litmus paper as well as the blue litmus paper. When you dip in it, what happens? Red litmus paper does not show any change in color, but the blue litmus paper change its color to red. So we can say that, okay, non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. Why? Because you can see, I told you here, when I dipped in it, what happened? The blue litmus paper changed its color to red. Understand? I'm sorry, children. Blue litmus paper changes color into red. Very important, you want to understand. So this example also they can ask in the exam. Okay, so very important, children. Yes, see, basically what you have to understand, Basically, you want to understand metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. Okay, metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. I have given two examples here. One is I told about carbon dioxide. Carbon dioxide is basically toxic in nature. So it is acidic in nature. It is a non-metal. Non-metals are acidic in nature. Okay, I think you are clear with this doubt. Do you have any doubt in this particular topic, children? Shall I move forward? Yes. Shall I move forward? Yes, fastly. Yes. So few are asking, yes, yes, ma'am, we have understood. Few are saying, once again, ma'am. Okay. Let me give you a quick review. Very quick, okay. Because most of you have the other work also. I don't want to disturb everybody. Okay. Very quickly. So those who are saying once again, see, basically metallic oxides are basic in nature because see, when we react the metallic oxide with an acid, you have seen that a salt is formed. The formed salt is basic in nature. So please check out the activity. You will understand very simple, very simple. When we dip the red litmus paper into a metallic oxides product, it turns out it's the color to blue. That means it is basic in nature. So I told you about sulfur just now. When you burn the sulfur, we got sulfur dioxide, or the gas which has been released by the sulfur is sulfur dioxide. After collecting this gas, mix it into the water, you get an acidic nature solution. So dip the blue litmus paper as well as the red litmus paper. You will find that blue litmus paper is changing its color to red. This shows that the non-metallic oxide, non-metals, see, dear student, the one who is saying, ma'am, I did not understand. Remember one thing, metallic oxide, MOB, okay, metallic oxides are basic in nature. Non-metallic oxides, NMOA, non-metallic oxides are acidic in nature. Okay, metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. Yes, fine. So now let us understand the next concept. Okay, so fine. The next concept is glance me once. So this is specially I prepared for you because whatever I taught you now once has to be glanced before going to next concept. Fine. See, reaction, we have till now we have understood about reaction of acids with the metal carbonate. We have understood with the metal hydrogen carbonate, metal oxide and base. Very important. Now ಅಷ್ಟು ನಾ ಏನು ಕಲ್ತ್ಕೊಂಡ್ವಿ ಅದಷ್ಟು ಕೂಡ ಇಲ್ಲೇ ನೋಡಿ ಇದೆ. When acid react with metal carbonate, what is the product form? Salt, carbon dioxide and water. ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಬೇಕು. Similarly, when the acid react with the metal, it produces salt and hydrogen gas. When acid react with metal hydrogen carbonate, it also produces carbon dioxide and water. When acid react with metal oxide, it produces salt and water. When acid react with base, it also produces salt and water. ಒಂದೇ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, metal carbonate ಆಗಿರ್ಬೋದು, metal hydrogen carbonate ಆಗಿರ್ಬೋದು, product is same. Okay, when acid react with these two. When acid react with metal oxide or base, their products are same, salt and water. But when acid react with metal, it releases the hydrogen gas. So to test this, whatever we do, you know it. ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ already, you know it. Yes. Now, similarly, what happens when base react with metal carbonate, metal hydrogen carbonate, acid and also non-metallic oxide, we have understood. See, when a base react with a metal, it produces salt and hydrogen gas. When the same base, when it react with the metal carbonate, let us take any base, children. You can take sodium hydroxide, calcium hydroxide, any base you can take. When a base react with metal carbonate, there is no reaction. When a base react with metal hydrogen carbonate, also no reaction. But when a base react with acid, it produces salt and water. And the same base, when it is reacting with the non-metallic oxide, last part we have studied about sulfur, it produces salt and water. This particular ನೋಡಿ ಇಷ್ಟು ಗೊತ್ತಿದ್ರೆ ನಿಮಗೆ ಮೇಲೆ ನಾನು ಇಷ್ಟೊತ್ತು ಏನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ ಅದಷ್ಟು ಕೂಡ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಇಷ್ಟು ಗೊತ್ತಿರ್ಬೇಕು ನಿಮ್ಗೆ, ಇಂಪಾರ್ಟೆಂಟ್. ಇಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿದ್ರೆ ನಿಮ್ಗೆ ನಾನು ಮೇಲೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದಂತ ಎಲ್ಲಾ ಕಾನ್ಸೆಪ್ಟ್ ಕೂಡ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಓಕೆ, fine. So now let us understand about what do all the acids and all the bases have common in. ಎಲ್ಲ ಆಸಿಡ್ಸ್ ಅಲ್ಲೂ ಎಲ್ಲ ಬೇಸಸ್ ಅಲ್ಲೂ ಏನು ಕಾಮನ್ ಆಗಿರುತ್ತೆ? ವಾಟ್ ಇಸ್ ಕಾಮನ್? Already at the beginning of the session I told you, dear students. At the beginning of session I told you. Yes. So I request the students to avoid the unwanted or interrupting message in the comment area, so you can focus on your studies. So this session is especially dedicated for your examination, that you all can score very good marks. Yes. See, all the acids have H plus ions and all the bases have OH minus ions. Very common. But the acid which produces H plus ions in a solution are responsible for producing the acidic property in that solution. Similarly, if it is containing OH minus ions, it have the basic properties. Very easy, children, because at the beginning of the class, only today's class, I told you. So what is meant by acid? What do acid contain? Acid contain H plus ions, bases contain OH minus ions. Okay, very importantly, you want to know this concept. Yes, similarly, I have represented this. See, all acids contain H plus ions, all bases contain OH minus ions. So how do we say weak acid, weak base, strong acid, strong base? I already told you. Okay, strong acid is nothing but it has more H plus ions. Weak acid is nothing but it has less H plus ions. Concentration is less. Similarly, strong base is having more OH minus ions. Weak base is having less OH minus ions. Okay. The next concept is acids or base in water solution. Okay. See, acid, what do it produces in the water? See, when acid is added to water, it produces the H plus ions. Very important. Here 2 marks question they can ask in exam. 2 marks question anna keluvanta chances irutte. Okay. See, acids produces H plus ions in the water, in the presence of water actually. So ಇದಕ್ಕೆ ರಿಲೇಟೆಡ್ ಆಗಿ ನಿಮಗೆ ಆಕ್ಟಿವಿಟಿ 2.9 ಆಕ್ಟಿವಿಟಿ 2. ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಲ್ಲಿ ಇದೆ, ಪೇಜ್ ನಂಬರ್ 23 ನಲ್ಲಿ ಇದೆ. ಪೇಜ್ ನಂಬರ್ 23 ನಲ್ಲಿ ಆಕ್ಟಿವಿಟಿ 2.9 ಇದೆ. ಆಕ್ಟಿವಿಟಿ 2.9 ನಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ, ಸೊ ಒಂದು ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ತಗೊಳಕ್ ಹೇಳ್ತಾರೆ. ಟೇಕ್ ಅ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್. ಓಕೆ, ಅಂಡ್ ಇನ್ ದಿಸ್ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ ನಾವು ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ವಿಚ್ ಇಸ್ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ NaCl. ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ನ ತಗೊಳ್ಳೋಣ. ಸೊ ತಗೊಂಡಂತ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಗೆ ನಾವು ವಿ ಆರ್ ಆಡಿಂಗ್ ದ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಆಸಿಡ್, not the diluted. Now we are adding the concentrated sulfuric acid, that is H2SO4. And remember children, when we are adding the concentrated acid, we have to add very carefully and drop by drop. So we are adding the concentrated sulfuric acid to the sodium chloride solution. Okay, this is activity 2.9. So when we add this, what happened? It releases a gas. So the released gas, we have to know what is it. We have to identify which gas is released. If we take a blue litmus paper here, this blue litmus paper does not show any change in the color. But if the same blue litmus paper, if it is dipped in the water and bring it to this particular region, it shows the nature of the presence of the hydrochloric acid. Okay, it releases. See here, when sodium chloride is combining with sulfuric acid, it releases the HCl gas. It releases the HCl gas, children. So this HCl gas does not show the nature in the dry litmus paper. But if we take the wet litmus paper here, what happened? It shows the presence of H plus ions. That is why we are saying acid produces H plus ions only in the presence of water. So in textbook they have given in page number 23, very important concept here. Acid produces H plus ions only in the presence of water. In the absence of water, you cannot check out the acidic property. Yes. See, H plus ions, that means that is acidic nature. H plus ions cannot exist alone. They exist as H3O plus, that means hydronium ions. I repeat once again. See, hydrogen ions cannot exist. H plus ions means hydrogen ions. They cannot exist alone. Okay. But they exist only after combining with the water. ಯಾವಾಗ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ? ಓನ್ಲಿ ವೆನ್ ದೇ ಕಂಬೈನ್ ವಿತ್ ದ ವಾಟರ್. ಸೊ ಅದರಿಂದ ಏನಾಗುತ್ತೆ? ಹೈಡ್ರೋಜನ್ ಅಯಾನ್ಸ್ ಮಸ್ಟ್ ಆಲ್ವೇಸ್ ಬಿ ಶೋನ್. ಇಟ್ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಶೋನ್ ಆಸ್ AQ. ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ಶೋನ್ ಆಸ್ aqueous. ಬಿಕಾಸ್ aqueous ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ? ದ ಸಾಲ್ವೆಂಟ್ ಈಸ್ ವಾಟರ್. ದ ಸಾಲ್ವೆಂಟ್ ಈಸ್ ವಾಟರ್. ಸೊ ಇಟ್ ಈಸ್ ಓನ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ವಾಟರ್. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಸೊ H plus ions cannot exist alone. They exist as H3O plus. In the presence of water, it exists. Very important, children. See, here H plus is nothing but an acid. See, acid, when it is combining with water, it is showing its nature as hydronium ion. Understand? Very importantly, you want to understand, children. Okay? Yes. So this particular concept, I think you all are clear with this concept. We will move ahead to understand the next concept. Yes. The next concept is bases when it is dissolved in the water. Okay. See, bases, when it is dissolved in the water, it gives rise to OH minus ions. Very important. Bases, when it is dissolved in the water, it gives rise to OH minus ions, dear students. ನೋಡಿ ಈ ಕಂಪ್ಲೀಟ್ ಲೆಸನ್ ನಾನು ಏನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಿಮಗೆ 6 ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ ಇದರಿಂದ. ಸೊ ಕ್ಲಿಯರ್ ಆಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ, 6 ಮಾರ್ಕ್ಸ್ ಡೆಫಿನೆಟ್ಲಿ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ ಇದರಿಂದ. ಓಕೆನಾ? ಸೊ ಅದರಿಂದ ನೀವು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಲೆಸನ್ ನ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಸೊ ಬೇಸಸ್ when it is dissolved in the water, it produces the OH minus ions. Yes. So let us see. The sodium hydroxide, when it is dissolved in the water, I get sodium and hydroxide. Magnesium hydroxide, when it is dissolved in the water, it produces magnesium and hydroxide. And already ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೀನಿ, bases which are soluble in the water are called as alkalis. What is meant by alkali? Alkali is nothing but the bases that are soluble in water. Bases that are soluble in water are called as, okay, bases which are soluble in water are called as alkalis. Very important, dear students. Very importantly, you want to understand, this is a very, very important topic. 1 mark ge keltare. Okay? And you can also write examples: sodium hydroxide, magnesium hydroxide, calcium hydroxide. They are all the examples for the bases which are soluble in water. Next concept, see hereafter I am dealing with the dilution, pH level, and also some of the uses of the important topics which you need to understand from this lesson. Dilution. Dilution ಬಗ್ಗೆ ಕೂಡ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರೆ. See, while diluting an acid, okay, it is recommended that acid should be added to water but not water to acid. ಈ ರೀತಿ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. Why we have to add the acid to water but not the water to acid? While diluting, what happened? We always have to, for example, if here is a beaker, we have to first take the water in it. Okay. See, we always have to add the acid to water drop by drop. We should not take the acid and add the water to it. Why? They are asking. Why? Do you know why it is? Do you know what is the reason behind this? Okay, I'm asking you the answer. Do you know what is the reason behind this? Yes. So if you are trying to answer, yes, very good. So it is because, see, when we add the water to acid, what happens? This acid will splash out like this. It will splash out. So as it is splashing out, you will get the burns on your hand. This mixture will splash because when you add the water to acid, it will this is, this beaker will get heated immediately. It will become heat as it is an exothermic reaction. You know what is exothermic reaction? The reaction which produces the more amount of heat, huge amount of heat. We will say it as exothermic reaction. See, when you add the water to acid, it releases more amount of heat, and this is a wrong way of dilution. Always you have to add the acid to water drop by drop for dilution. Understand? If you perform this method, what happens? You don't have any problem. But if you perform this method, definitely you will have problems. Okay. See, I have given the reason also. Because the process of dissolving an acid or a base in the water is highly exothermic because it releases the heat. If the water is added to acid, it generates the heat and it causes the mixture to splash. Splash ಆಗುತ್ತೆ. And it also causes the burn. Sometimes this glass container may also break due to the local excessive heating. Heat increase ಆಗುತ್ತೆ, ಅದರಿಂದ glass break ಆಗುತ್ತೆ. Okay, this is importantly you want to understand. Okay, exam ಅಲ್ಲಿ reason ಕೇಳ್ತಾರೆ dear students. So why do we have to add the acid to water but not the water to acid? You have to write why. Because adding the water to acid is a highly exothermic reaction, it may, generate a huge amount of heat. It will the mixture may splash out, and it also causes the burn and the burns at the baribeku. So what you have to do, always you have to add the acid to water, but not the water to acid. Yes, clear. So this one, I think you're clear with this. So adding water to acid may cause the mixture to splash out. Adding water to acid may cause the mixture to splash out, and it breaks the glass container. This point I've already explained you. I think no need to repeat it once again. So now let us understand the strength of acid and base. How can you identify the strength of acid and base? You can identify the strength of acid and the strength of base by estimating using the universal indicator. Already you have come across a word called indicator. Indicator ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ದೀರಾ. So today's class will be little delay children. ಸ್ವಲ್ಪ ಲೇಟ್ ಆಗುತ್ತೆ. Stay back ಆಗಿ exit ಆಗಬೇಡಿ. ನಿಮಗೆ ಸ್ಕೂಲಿಗೆ ಟೈಮ್ ಇರುತ್ತೆ. So don't exit, because this is going to give you a best revision for you for your examination preparation. Yes. Okay. Strength of an acid and base can be estimated by using the universal indicator. So what is meant by universal indicator then? See, universal indicator is a mixture of several indicators. Already ನಾನು ನಿಮಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲೇ ಹೇಳಿದ್ದೀನಿ indicators ಅಂತ ಏನು ಅಂತ. ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೀನಿ indicators ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಬೇಕು. It's very important. See, this shows whether the, for example, if we have the different colors, let us take some different solution. Let us take sodium hydroxide solution. Let us take some carbonic solution, and let us take some the soda solution, or let us take some anything, or coffee, or any solution you take, children. Okay, so when you add the indicator to this solutions, what happens? It will show change in the color. Okay, so it shows whether the solution is acidic or basic. So universal indicator is the mixture of several indicators. It shows the different colors at the different concentration. Very importantly, you want to understand. Okay, yes, fine. So now we are up with a very important concept most of the students were asking. So I think other 20 minutes, I think, children, 20 minutes, because we have a still more important concept. I'll try to complete within 20 minutes. Yes. So pH value, someone is asking, and thank you, somebody has credited the chart revenue also. Thank you. It's a love and affection which you're showing towards me. Yes. Fine. So pH value. Fine. What is meant by pH? pH is nothing but the potential hydrogen, children. pH is nothing but the potential hydrogen. So here, if we write the pH scale, it starts from 0 and it will end at 14. Okay. And in the middle, there is 7. So there are numbers 0, 1, 2, 3, 4, 5, 6, 7 till here 7. Okay. And then 8, 9, 10, 11 till 14. 0 to 14. So if the pH level is 7, the pH level of a solution is 7, then the solution is called as neutral solution. If the pH is less than 7, if it is less than 7, then the solution is acidic. If the pH level of that solution is more than 7, then it is basic in nature. Acidic in nature, basic in nature. Very importantly, you want to understand. Okay, very important. pH scale, it starts from 0, end at 14. Okay, 0 to 7 is acidic, 7 to 14 is basic. 0 to 7 acidic. Acidic andre enirutte? It contain more amount of H plus ions. Okay, so basic 7 to 14 basic. Basic andre enagutte? It contain more amount of OH minus ions. So 7 andre enu helde? 7 is neutral. 7 is neutral. Children, at this particular point of view time, I would like to tell you one thing. Enandre ಕೆಲವರಿಗೆ ಡೌಟ್ ಇದೆ, ಮ್ಯಾಮ್ ಬೇಸಿಕ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ H plus ions ಇರಲ್ವಾ? whether the basic solution does not contain H plus ions ಇರಲ್ವಾ ಅಂತ ಕೇಳ್ತಾರೆ. See, basic solution also contain H plus ions. Similarly, acidic solution also contain OH minus ions, but basic solution contain more amount of OH minus ions compared to H plus ions. That is why this is basic. Similarly, acidic solution contain more amount of H plus ions compared to OH minus ions, hence it is acidic. Artha agtide alva? Very importantly, you want to understand. Okay, very importantly, you want to understand. Yes, so OH minus ions ide andre acidic alla, basic. H plus ions ide andre adu acidic. Very importantly, you want to understand. Okay, so pH of pH, if it is below 7, it is acidic. Above 7, it is basic. If it is 7, it is neutral in nature. If it is 7, it is neutral in nature. Yes. Okay. Look at this, children. On diluting an acid, for example, if we take the beaker, okay, take the water in it, okay, what happened? If we take the water in it, add the acid to it, what are we doing here? We are diluting the acid. When we dilute the acid, what happened? pH level will, on diluting an acid, what happened? The pH level will increase. On diluting the base, the pH level will decrease. You have to understand this. Okay, on diluting the acid, the pH level will increase. On diluting the base, pH level, but this particular topic is not asked. It's an extra added topic here for you. No need to get confusion. Very easy, children. Remember, if it is 0 to 7, it is acidic in nature. 7 to 14, it is basic in nature. 7 is neutral. Okay. For example, as I told you, see what I told you, acidic nature, I told you just now. On diluting an acid, pH level will increase. See, pH level now what happened? It is increasing. Can you see? It is increasing. If it is increasing, what happened? H plus ion concentration will increase. See, if the on diluting the base, what happened? pH level will decrease. Okay. If it is decreasing, what happened? H plus concentration will decrease. OH minus ions concentration will increase. OH minus ion concentration ಏನಾಗುತ್ತೆ? Increase ಆಗುತ್ತೆ. Okay? Yes. So I think ನಿಮ್ಗೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ನನಗೆ ಹೇಗೆ ಇಲ್ಲಿ ಹೇಳಿದಾಗ ಡೌಟ್ ಆಯ್ತು ಅಂತ ಅನ್ಕೋತೀನಿ. I think now you are clear. Why it increases, why it decreases. ಡೈಲ್ಯೂಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ನೋಡಿ. H plus ions ಏನಾಗುತ್ತೆ? ಇವಾಗ ಇಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಡೈಲ್ಯೂಟ್ ಆದಾಗ. Fine. You have any doubt, children? Do you have any doubt? Shall I move ahead? Once again, I say you, on diluting an acid, acidic, you can see, and diluting an acid, okay, on diluting a base, pH increases and pH decreases. Okay, but importantly, you want to understand, in examination, they will ask you, see, they may give you solution A, B, C, D are given, okay, solution A, B, C, D are given, which is having a pH value of 7, pH value of 6, pH value of 5 and pH value of 8. Okay. Among this, which is more acidic? Which is more acidic andre ಏನು ಹೇಳ್ತೀರಾ? Which is more acidic here? Okay. Which is more acidic here? Tell me. Which is more acidic, children? Okay, already many are answering C. Very good. So Venkatesh, Tulsi, Kirtana, Craft, Home, Hanumappa Nayak and Sahana, many are answering, Anushri and all. Very good. See, this is having more acidic in nature. This is more acidic in nature. Even this is also acidic, but when it is lesser the number, more the acidic in nature. Understand? So compared to 6, that is 5 is having more acidic in nature. So which is more basic? Which is more basic? Which is more basic, dear students? Very good. Sonia has given the correct answer. D is more basic. Even A is having basic in nature, but it is neutral in nature. So when we talk about basic nature, D is more basic. D is more basic. Okay. I think you are clear with this topic. Now let us understand the pH in everyday life. See, plants and animals are very sensitive to pH, dear students. So our body works within the range of pH range of 7 to 7.8. Sometimes it might be asked in the exam. Exam ali keltare, what is the pH value of a human body? So human body's pH range is between 7 to 7.8, neutral to basic in nature. Next, when pH of rainwater is less than 5.6, you have to remember it is acid rain. pH of rainwater is 5.6, it is acidic in nature. Okay, that is why we will call it as acid rain. So I just go quickly because these are all very simple concept. Okay, then pH of soil. See, plants require a specific pH range for their healthy growth. For example, if a farmer is cultivating the crops, he need the soil to be tested. Okay, so he'll take the soil for testing to know whether the soil is acidic or basic. If it is acidic, the crops will not grow in a healthy manner. So if it is, if the pH of soil is more, what happens? We have to add the base for it. If the soil is having more pH value, we have to add the base for it. Only then the plants will grow healthily. Then pH in our stomach, we call it as digestive system. Okay. So in our stomach, what happened? You know that in life process lesson I told you, your stomach produces the HCl. HCl is nothing but hydrochloric acid. So this HCl will help in digestion and also it kills the microorganisms. You know this. Okay. So pH in our digestive system, our stomach helps to produce the HCl acid, which is helping digestion. So what happened? That is why the pH of the stomach is more. pH of your stomach is more because it is acidic in nature, no? So that is why the pH is more. Next, during the indigestion, when you are having indigestion problem, the stomach produces too much of acid and it causes pain and irritation. I think you know about this concept. They will ask the give reason question. Give reason question ಕೇಳ್ತಾರೆ. So ನಿಮ್ಮ ಸ್ಟಮಕ್ ಅಲ್ಲಿ ಒಂದ್ ವೇಳೆ ಏನಾಗುತ್ತೆ ಎಕ್ಸೆಸ್ ಆಫ್ ಆಸಿಡ್ ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಇದು ಏನಾಗುತ್ತೆ ನಿಮ್ಗೆ ಇಂಡೈಜೆಷನ್ ಆದಾಗ ಈ ಪ್ರಾಬ್ಲಮ್ ಆಗೋದು. ಎಕ್ಸೆಸ್ ಆಫ್ ಆಸಿಡ್ ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಯು ಹ್ಯಾವ್ ದ ಸ್ಟಮಕ್ ಪೇನ್, ಇರಿಟೇಷನ್ ಆಗುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಏನ್ ಮಾಡ್ತೀರಾ ಈ ಟೈಮ್ ಅಲ್ಲಿ? ಆಸಿಡ್ ರಿಲೀಸ್ ಆಗ್ತಾ ಇದೆ ಹೆಚ್ಚಾಗಿ ಅಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ಯು ಹ್ಯಾವ್ ಟು ಆಡ್ ದ ಬೇಸ್ ಟು ಇಟ್. ಸೊ ಯಾವ ಬೇಸ್ ಅನ್ನ ಆಡ್ ಮಾಡ್ತೀರಾ? ಸೊ ಈ ಪ್ರಾಬ್ಲಮ್ ಇಂದ ಹೊರಗಡೆ ಬರಕ್ಕೆ ಯು ವಿಲ್ ಆಡ್ ಅ ಬೇಸ್ ಕಾಲ್ಡ್ ಆಂಟಾಸಿಡ್. ಸೊ ಆಂಟಾಸಿಡ್ ನ ಆಡ್ ಮಾಡ್ತೀರಾ. ಆಂಟಾಸಿಡ್ ವಿಚ್ ಇಸ್ ಸೋ ಕಾಲ್ಡ್ ಮಿಲ್ಕ್ ಆಫ್ ಮೆಗ್ನೀಷಿಯಂ ಅಂತ ನಿಮ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿದರೆ. ಮೆಗ್ನೀಷಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್, ಮೆಗ್ನೀಷಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಇಸ್ ಕಾಲ್ಡ್ as ಮಿಲ್ಕ್ ಆಫ್ ಮೆಗ್ನೀಷಿಯಂ. ಸೊ ರಿಲೀಸ್ ಆದಂತ ಈ ಆಸಿಡ್ ಗೆ ನೀವು ಬೇಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಿದಾಗ ನಿಮ್ಮ ಸ್ಟಮಕ್ ಗೆ, ಹೌ ಡು ಯು ಆಡ್? ಥ್ರೂ ಯೋರ್ ಮೌತ್ ಯು ಆಡ್. ಓಕೆ. ಸೊ ಬೇಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಆಸಿಡ್ ಕಂಬೈನ್ಸ್ ವಿತ್ ದ ಬೇಸ್. ಯು ನೋ ದಟ್ ಇಟ್ ಈಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್. ಸೊ ನ್ಯೂಟ್ರಲೈಸ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಏನಾಗುತ್ತೆ? ಆ ಸ್ಟಮಕ್ ಪೇನ್ ಅಥವಾ ಇರಿಟೇಷನ್ ಏನಾಗುತ್ತೆ? ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ನೀವು ಇವಾಗ ಅಡ್ವರ್ಟೈಸ್ಮೆಂಟ್ ಏನ್ ನೋಡ್ತೀರಾ, ಈನೋ ಆಗಿರ್ಬೋದು, ಜೆಲುಸಿಲ್ ಆಗಿರ್ಬೋದು, ಇದೆಲ್ಲ ಈ ಬಾಟಲ್ಸ್ ನ ನೀವು ಚೆಕ್ ಮಾಡಿ, ಅದ್ರ ಮೇಲೆ ಬೇಸಿಕ್ ನೇಚರ್ ಇರುತ್ತೆ. ಸೊ ಬೇಸಿಕ್ ನೇಚರ್ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? ಇದು ಆಸಿಡ್ ಅನ್ನ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡುತ್ತೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನೆಕ್ಸ್ಟ್, pH ಚೇಂಜ್ ಆಸ್ ಇಟ್ ಕಾಸಸ್ ದ ಟೂತ್ ಡಿಕೆ. ನೋಡಿ, ನಿಮ್ಮ ಟೂತ್ ಡಿಕೆ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಯಾವಾಗ ಡಿಕೆ ಆಗುತ್ತೆ ಅಂದ್ರೆ ವೆನ್ ಯುವರ್ ಮೌತ್, the pH of your mouth is lower than 5.5. 5.5 is, you know that it is acidic in nature. So your tooth decay start when the pH value is lesser than 5.5. So again ಆಗುತ್ತೆ, tooth enamel ಏನಾಗುತ್ತೆ? ಇದು ಮೆಲ್ಟ್ ಆಗಕ್ಕೆ ಶುರು ಮಾಡುತ್ತೆ. You have to know that your tooth enamel is made up of calcium phosphate. And this is one of the hardest substance in your body. Your teeth is the hardest substance in your body, which is made up of calcium phosphate. So it does not dissolve very easily. Dissolve ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ತುಂಬಾ hardest substance. It does not dissolve in water or it does not corrode. Damage ಆಗಲ್ಲ. ಯಾವಾಗ ಡ್ಯಾಮೇಜ್ ಆಗುತ್ತೆ ಇದು ಅಂದ್ರೆ when the pH value of your mouth is lower than 5.5. ಯಾಕಂದ್ರೆ ಅವಾಗ ಆಸಿಡಿಕ್ ನೇಚರ್ ಇರುತ್ತೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಸೊ ಇಟ್ ಇಸ್ ಆಸಿಡಿಕ್ ಇನ್ ನೇಚರ್. ಆಗ ಏನಾಗುತ್ತೆ? ನಿಮ್ಮ ಮೌತ್ ನಲ್ಲಿರುವಂತ ಆ ಟೂತ್ ಏನಾಗುತ್ತೆ? ಡಿಕೆ ಆಗಕ್ಕೆ ಶುರು ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಆಲ್ಸೋ ಪ್ರೊಡ್ಯೂಸ್, ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಹ್ಯಾಪನ್. ಅಂದ್ರೆ ಯಾವ ರೀತಿ pH ವ್ಯಾಲ್ಯೂ 5.5 ಆಗುತ್ತೆ ಮ್ಯಾಮ್ ಅಂತ ನೀವು ಕೇಳ್ಬೋದು. ಹೌ ಡಸ್ ದಿಸ್ pH reduces to 5.5? See, the pH value reduces to 5.5 as a result of the degradation of food particles. ಕೆಲವೊಮ್ಮೆ ಏನ್ ಮಾಡ್ತೀರಾ? ವಾಟ್ ಎವರ್ ದ ಫುಡ್ ಯು ಈಟ್, you might not have properly brushed your teeth or you might have not cleansed your mouth. So ಆಗ ಏನಾಗುತ್ತೆ? some amount of food left over in your mouth only. So ಅದೇನಾಗುತ್ತೆ? degrade ಆಗುತ್ತೆ. Okay. So ಆಗ ಏನಾಗುತ್ತೆ? bacteria increases. When there is degradation of food particles in your mouth, bacteria increases, bacterial activity increases. As a result of it, the pH value decreases. When the pH value decreases, your tooth will decay. Very important. ಅರ್ಥ ಆಯ್ತು ಅನ್ಕೋತೀನಿ. ಸೊ ಈಗ ಟೂತ್ ಏನೋ ಡಿಕೆ ಆಗ್ತಾ ಇದೆ. ಹೌ ಡು ಯು ಅವಾಯ್ಡ್, ಹೌ ಡು ಯು ಪ್ರಿವೆಂಟ್ ಯುವರ್ ಟೂತ್ ಡಿಕೆ? ಯು ವಿಲ್ ಯೂಸ್ ದ ಟೂತ್ ಪೇಸ್ಟ್. ವೈ ಡು ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ಟೂತ್ ಪೇಸ್ಟ್? ಯಾಕೆ ಟೂತ್ ಪೇಸ್ಟ್ ನ ಯೂಸ್ ಮಾಡಬೇಕು? ಬಿಕಾಸ್ ದ ಟೂತ್ ಪೇಸ್ಟ್ ಕಂಟೈನ್ ದ ಬೇಸಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ಇನ್ ಇಟ್. ಇಟ್ ಕಂಟೈನ್ ದ ಬೇಸಿಕ್ ಪ್ರಾಪರ್ಟಿ. ಬೇಸಿಕ್ ಪ್ರಾಪರ್ಟಿ ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? ಈ ಟೂತ್ ಪೇಸ್ಟ್ ನ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಕ್ಲಿಯರ್? ಎಸ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ಕೇಳ್ತಾರೆ, ಸೆಲ್ಫ್ ಡಿಫೆನ್ಸ್ ಬೈ ಅನಿಮಲ್ಸ್ ಅಂಡ್ ಪ್ಲಾಂಟ್ಸ್ ಥ್ರೂ ದ ಕೆಮಿಕಲ್ ವಾರ್ಫೇರ್. ಏನಿದು? ಸಿ, ಆಸ್ ವಿ ಆರ್ ಕಮಿಂಗ್ ಅಕ್ರಾಸ್ ದ ಆಸಿಡ್ಸ್ ಅಂಡ್ ಬೇಸ್ ಇನ್ ಅವರ್ ಡೈಲಿ ಲೈಫ್, ಯು ಮೈಟ್ ಹ್ಯಾವ್ ಕಮ್ ಅಕ್ರಾಸ್ ದಿಸ್ ವರ್ಡ್. ಎಕ್ಸಾಂಪಲ್ ಕೇಳ್ತಾರೆ, ಬೀ ಸ್ಟಿಂಗ್ ಲೀವ್ಸ್ ಅನ್ ಆಸಿಡ್ ವಿಚ್ ಕಾಸಸ್ ದ ಪೇನ್ ಅಂಡ್ ಇರಿಟೇಷನ್. ಹೌ ಕ್ಯಾನ್ ಯು ಮ್ಯಾನೇಜ್ ದಿಸ್ ಸಿಚುಯೇಷನ್ ಅಂತ ಕೇಳ್ಬೋದು. ಬಿ ಸ್ಟಿಂಗ್, ಯಾವ್ದಾದ್ರು ಒಂದು ಬಿ ಆಗಿರ್ಬೋದು, ಇನ್ಸೆಕ್ಟ್ ಆಗಿರ್ಬೋದು, ನಿಮ್ನ ಸ್ಟಿಂಗ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಟ್ ರಿಲೀಸಸ್ ಆಸಿಡ್ ಕಾಲ್ಡ್ as ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಇಟ್ ರಿಲೀಸಸ್ ಆಸಿಡ್ ಕಾಲ್ಡ್ as ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್. And this methanoic acid is also having the other name called as formic acid. Methanoic acid or formic acid is being released. Okay, so when it is being released into your body, you feel irritation. ನಿಮ್ಗೆ ಇರಿಟೇಷನ್ ಆಗುತ್ತೆ, ಪೇನ್ ಆಗುತ್ತೆ. ಸೊ ಆ ಪೇನ್ ಅಂಡ್ ಇರಿಟೇಷನ್ ಅನ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡಕ್ಕೆ, ಆಸ್ ಇಟ್ ಈಸ್ ಆಸಿಡ್, you have to add the base on it. So what will you do? You go to kitchen, take some baking soda, okay, rub the baking soda on the area where the bee stung. ಎಲ್ಲಿ ಬೀ ಸ್ಟಂಗ್ ಮಾಡಿರುತ್ತೆ ನಿಮ್ಗೆ ಆ ಒಂದು ಏರಿಯಾದಲ್ಲಿ ಏನ್ ಮಾಡಿ, ಈ ಒಂದು ಬೇಕಿಂಗ್ ಸೋಡಾನ ರಬ್ ಮಾಡಿ. ಸೊ ಏನಾಗುತ್ತೆ, ಆಸಿಡ್ ಹ್ಯಾಸ್ ಕಂಬೈನ್ಡ್ ವಿತ್ ಬೇಸ್, ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್ ಕಂಬೈನ್ಡ್ ವಿತ್ ದ ಬೇಕಿಂಗ್ ಸೋಡಾ. ಆಸ್ ಅ ರಿಸಲ್ಟ್ ಆಫ್ ಇಟ್ ಏನಾಯ್ತು, ನಿಮ್ಗೆ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಯ್ತು. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಓಕೆ, ಸೊ ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್ಗೆ ಇರುವಂತ ಇನ್ನೊಂದು ನೇಮ್ ಬಂದು ಫಾರ್ಮಿಕ್ ಆಸಿಡ್. ನಿಮ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಸಪೋಸ್ ಇಫ್ ದೇ ಆಸ್ಕ್ ಇನ್ ದ ಮಲ್ಟಿಪಲ್ ಚಾಯ್ಸ್ ಕ್ವೆಶನ್, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್, ಇಫ್ ದೇ ಆಸ್ಕ್ ಫಾರ್ಮಿಕ್ ಆಸಿಡ್, ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದಟ್ ಈಸ್ ದ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. And also stinging of nettle leaves, ಅದರಲ್ಲೂ ಕೂಡ ಮೆಥನೋಯಿಕ್ ಆಸಿಡ್ ಇರುತ್ತೆ. It also causes burning, and when you rub the dock plant leaf on it, what happen, it gives the relaxation. So ಎಲ್ಲಿ ನಿಮ್ಗೆ ನೆಟಲ್ ಪ್ಲಾಂಟ್ ಇರುತ್ತೆ, ನೆಟಲ್ ಲೀಫ್ ಪ್ಲಾಂಟ್, ಅಲ್ಲೇ ಡಾಕ್ ಪ್ಲಾಂಟ್ ಇರುತ್ತೆ. ಸೊ ಯೂಶಲಿ ನೀವು ಇದನ್ನ ಟ್ರಕ್ಕಿಂಗ್ ಮಾಡುವಾಗ ನೋಡ್ಬೋದು. ವೆನ್ ಯು ಟ್ರಕ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಸಪೋಸ್ ನಿಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಪ್ಲಾಂಟ್ ಟಚ್ ಆಗಿ ಇರಿಟೇಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, ದಟ್ ಈಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ದ ನೆಟಲ್ ಪ್ಲಾಂಟ್. ಸೊ ಅಲ್ಲೇ ಹತ್ತಿರದಲ್ಲಿ ಡಾಕ್ ಪ್ಲಾಂಟ್ ಇರುತ್ತೆ. ಇಫ್ ಯು ರಬ್, ಯು ಗೆಟ್ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಬಿಕಾಸ್ ಇಟ್ ಕಂಟೈನ್ಸ್ ದ ಬೇಸ್ ಇನ್ ಇಟ್. ಎಸ್, ಐ ಥಿಂಕ್ ನಿಮ್ಗೆ ಇದು ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೋತೀನಿ. ಎಸ್, ಸೊ ನೋಡಿ, ಪಿ ಎಚ್ ಆಫ್ ದ ಸಾಲ್ಟ್ಸ್ ಹೇಗಿರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಪ್ಲಸ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್, ಸ್ಟ್ರಾಂಗ್ ಏನು, ನ್ಯೂಟ್ರಲ್. ಸೊ ನ್ಯೂಟ್ರಲ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ, ಪಿ ಎಚ್ ವ್ಯಾಲ್ಯೂ 7. ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಅಂಡ್ ವೀಕ್ ಬೇಸ್, ಯಾವ್ದು ಸ್ಟ್ರಾಂಗ್ ಆಗಿದೆ, ಸಾಲ್ಟ್ ಸ್ಟ್ರಾಂಗ್ ಆಗಿದೆ. ಸೊ ಅದಕ್ಕೆ ಆಸಿಡಿಕ್ ಸಾಲ್ಟ್, ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡಿಕ್ ಸಾಲ್ಟ್. ನೋಡಿ, ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಅಂದ್ರೆ ಯಾವ್ದು ಸ್ಟ್ರಾಂಗ್ ಆಗಿದೆ, ಸಾಲ್ಟ್ ಇಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಆಗಿದೆ. ಓಕೆ, ಅದರಿಂದ ನಮ್ಗೆ ಆನ್ಸರ್ ಏನ್ ಬರುತ್ತೆ, ಆಸಿಡಿಕ್ ಸಾಲ್ಟ್. ಪಿ ಎಚ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಗ್ರೇಟರ್ ದೆನ್ 7. ನೆಕ್ಸ್ಟ್, ಸಾಲ್ಟ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್, ಯಾವ್ದು ಸ್ಟ್ರಾಂಗ್ ಆಗಿದೆ, ಬೇಸ್ ಸ್ಟ್ರಾಂಗ್ ಆಗಿದೆ. ಸೊ ಬೇಸಿಕ್ ಸಾಲ್ಟ್. ಓಕೆ, ಫೈನ್. ಸೊ ನಿಮ್ಗೆ ಇದು ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೋತೀನಿ. ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ ಅಂತ ಅನ್ಕೋತೀನಿ. So let us glance the last part, very important part, last part ಗೆ ಬಂದಿದ್ದೀನಿ. You have to understand. So dock plant andre, it is a kind of plant, which has the basic properties in it. It has the basic properties in it. It's very important to know that wherever the nettle plant is there the dock plant is there to give the relaxation. You know that the nature is something which is giving remedy for everything. Okay, it is giving remedy for everything. Fine, we are up with the last concept of this lesson, and very important. In nimge illi 2 ಅಥವಾ 3 marks questions anna keltare, 2 marks ಅಥವಾ 3 marks question. Yes, first and foremost, before understanding the concept, basic things you want to understand. The name of the salts. Okay, sodium hydroxide, its name is its chemical formula is NaOH. Bleaching powder, okay, formula is CaOCl2, calcium oxychloride. Baking soda formula NaHCO3, sodium hydrogen carbonate. Washing soda formula Na2CO3, 10H2O. You should write here, you have to keep a dot and write 10H2O. And plaster of Paris, CaSO4, half H2O. Plaster of Paris, CaSO4, calcium sulfate. This is hemihydrate, half in the hemihydrate, calcium sulfate, hemihydrate. Okay na, very important. Yes, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಈ ಇಷ್ಟು ಫಾರ್ಮುಲಾಸ್ ನಿಮ್ಗೆ ಗೊತ್ತಿರ್ಬೇಕು. ಇಷ್ಟು ಫಾರ್ಮುಲಾಸ್ ನೀವು ಬರ್ಕೊಳ್ಳಿ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ನೀವು. ಈಗ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್. ದಿ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್, we are talking now first about here a chlor-alkali process. We are talking about a chlor-alkali process, very important. Diagram ಕೇಳಲ್ಲ dear students, they don't ask diagram in exam. Instead ಏನ್ ಕೇಳ್ತಾರೆ ಅಂದ್ರೆ diagram based question. Okay, please wait. Okay, 7:45, I think 7:45 ಆಗಿಲ್ಲ. So those who want to go for school, please, you can leave the class and go. The video will be uploaded. Okay, I will upload the video. You can watch it again. Okay, ನೀವು ಎಲ್ಲಿವರೆಗೂ ನೋಡಿದಿರಾ ಅಲ್ಲಿಂದ ಮುಂದಕ್ಕೆ ನೀವೇನ್ ಮಾಡಿ, when you come back from school, you can watch. Okay, yes, no issues, children. Those who are going, please carry on. Okay, don't be late for the school. So we are talking about chlor-alkali process. ಏನಾಗ್ತಾ ಇದೆ ಈ chlor-alkali process ಅಲ್ಲಿ, see, we will take, see this look like this. Chlor-alkali process ಅಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ, we will take the sodium that is the Excuse me, children. So in this chlor-alkali process, we will take the solution. Which solution? Sodium chloride solution we will take. So to this solution, we are passing. You can observe here, we have taken the sodium chloride solution here. So this sodium chloride solution ಗೆ ನಾವು ಏನು ಮಾಡ್ತಿದ್ದೀವಿ ಅಂದ್ರೆ we are passing the electricity. Understand? So we are passing the electricity to the sodium chloride solution. This is the aqueous solution. Okay. So electricity na pass ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? When the electricity is passed to sodium chloride solution or the brine solution ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ, ಈ sodium chloride ಏನಾಗುತ್ತೆ? Decompose ಆಗುತ್ತೆ. Decompose ಆಗಿ ಏನಾಗುತ್ತೆ? It releases the products. So what are the product released? You can observe here. See, when the sodium chloride is being decomposed, what happened? The product released are sodium hydroxide, chlorine and hydrogen. See, when we pass the electricity to this sodium chloride solution, so called this brine solution, naven ಮಾಡ್ತಾ ಇದೀವಿ. So ಇಲ್ಲಿ you can observe, just a moment students. As I was teaching you continuously, I just wanted a small break. Okay, fine. So when we pass the electricity to sodium chloride solution, what happened? This sodium chloride undergo decomposition. As it undergo decomposition, it releases two gases. One is the chlorine gas and one more is the hydrogen gas. Along with this, it also releases the sodium hydroxide. It releases the sodium hydroxide. Very importantly, in examination, they will ask you, name the products obtained during the chlor-alkali process. Okay, name the products obtained during the chlor-alkali process. The product obtained during the chlor-alkali process is the sodium hydroxide, chlorine gas and hydrogen gas. And here what importantly you want to understand, so where this chlorine gas is released, where this hydrogen gas is released, you want to understand. See, this diagram contains both the anode as well as the cathode. So this chlorine gas is released at the anode. Okay, chlorine gas is released at anode, whereas the hydrogen gas is released at the cathode. Very important, children, you have to note down. So chlorine gas is released at anode, hydrogen gas is released at the cathode. And what is the function of it, you want to understand? What is the function of all these three products which we obtained during the chlor-alkali process? So whatever the product we have obtained here, so you have to know the functions of it. Very important. In Akashvani program also, they said about this. I told you in this, about this. Okay. So what is the function of this? You can see. See, the function of these you have to clearly understand. See, as I told you, see, when we pass the electricity to sodium chloride, that is the aqueous solution of sodium chloride. So we got these products. We got hydrogen, we got chlorine, we also got the sodium hydroxide. Understand? You have understood hydrogen is released at the cathode and the chlorine is released at the anode. Fine. What is the function of hydrogen? Hydrogen gas is used to manufacture the fuel. It is also used to manufacture the margarine. Next, chlorine. Chlorine is used for water treatment. It is used in the PVC and CFC. That is sodium hydroxide. HCl is also there. HCl is a cleansing steel it is used in cleansing the steels and also for the medicine purpose, but it is not, let us not consider it as a product. Consider hydrogen, chlorine and sodium hydroxide. Okay. So sodium hydroxide it is used for degreasing the metals and it is also used to manufacture the soaps and also the paper making. Example 3 marks ge kelbodu nimge. Name the products obtained during the chlor-alkali process and mention its functions anta keltare. Okay, na? So the products obtained during the chlor-alkali process is hydrogen, chlorine and sodium hydroxide. And the uses, as I told you, you have to read all these uses. Okay, very important. Next, let us now understand about the bleaching powder, dear students. Bleaching powder. Okay. So bleaching powder, what is meant by bleaching powder? Bleaching powder formula is calcium oxychloride. So this bleaching powder is produced by the action of chlorine on the dry slaked lime. What is meant by slaked lime? You know, slaked lime is calcium hydroxide. When this chlorine gas is passed on this slaked lime, so-called calcium hydroxide, we get bleaching powder. Very simple. In exam, they may ask you, write the, I think somebody is saying that you're not able to understand one concept. Okay, I'll repeat it. See, in examination, they will ask you, Write the formation of bleaching powder and write any two uses of it, they will ask you. How do bleaching powder form? Bleaching powder is formed by the action of chlorine gas on calcium hydroxide. When we pass the chlorine gas to calcium hydroxide, we get the bleaching powder. What is the uses of it? See, bleaching powder is used to bleach the cotton and also linen in the textile industry. And bleaching powder is used to bleach the wood pulp in paper industries. It is also used as an oxidizing agent in the chemical industries. It is also used as a disinfecting agent in the drinking water. When we add the bleaching powder to drinking water, it will kill all the microorganisms present in it. Okay, yes, fine. So I think you're clear with this. What is meant by bleaching powder? Bleaching powder is nothing but calcium oxychloride. How does it produce? It produces by passing the chlorine gas to calcium hydroxide. Very important. You should know the uses, children. They ask you in examination to write the uses. Okay. I think this particular part you have doubt. Someone is texting that, ma'am, I have doubt. I think this particular part. So dear student, what you have to learn here, I tell you. See, you want to know what is meant by chloralkali process. What is meant by chloralkali process? See, chloralkali process is a process where we are passing the electricity to aqueous solution of sodium chloride. So when the electricity is passed to the aqueous solution of sodium chloride, what happens? It releases the three products. You have to note down. So if we write the diagram, it will be like this. Electrodes will be here. So here it is anode, this is cathode, and here also there is a small place to release a product. So what happened? See, when this process is taking place, three products are released. One is the chlorine gas. Okay, chlorine gas is released. One more is the hydrogen gas is released. One more is the sodium hydroxide. As I told, this will be released here. So you should know what are the products released during the chloralkali process and what are its functions. Okay, so functions, as I told you, have to read these functions. Okay, yes. Now, okay, let me go for next concept, that is the baking soda. Very important concept, baking soda. What is meant by baking soda? Baking soda is nothing but the sodium hydrogen carbonate. Its formula is NaHCO3, dear students. Formula is NaHCO3. Okay, baking soda formula is NaHCO3. So, how do we get baking soda? See, when we add the water, carbon dioxide and NH3 ammonia to sodium chloride, when we add this, what happened? We get this product called as NH4Cl. I think you understood this. So we get NH4Cl. What is meant by NH4Cl? Already I told you just some time before. I told you what is meant by NH4Cl. So this NH4Cl is released along with this baking soda. You want to concentrate on this. So this the NH4Cl is nothing but the ammonium chloride. Ammonium chloride is released. So baking soda is the product of the sodium chloride, water, carbon dioxide and also the NH3. I think you all know the difference between NH3 and NH4. NH3 is nothing but ammonia. NH4 is nothing but ammonium. Okay. NH3 is ammonia. NH4 is ammonium, dear students. Okay. Yes. So this baking soda formula is NaHCO3. NaHCO3. In exam, they will ask you what are the functions of, what are the uses of baking soda. See, baking soda is actually used as a mild non-corrosive base, and baking soda is also used in cooking. Okay, it is used in the cooking. Very importantly, you want to understand. Fine. So, next important thing you want to understand here, children, how do we get the, I think you don't have any doubt in this particular concept. Do you have any doubt in this? If you are asking doubt, do you have any doubt in this? Yes, very good. Okay. So now we have taken the baking soda. So when we heat the baking soda, we get the Na2CO3. What is this Na2CO3? Na2CO3 is nothing but the washing soda, children. In exam, they may ask you, how do we get washing soda by baking soda? Or how baking soda? Yes, this is what they exactly ask in exam. How do we get the washing soda? By using the baking soda. See, when we heat the baking soda, just by heating, we get the baking soda, that is washing soda. What is the formula of washing soda? Actual formula of washing soda is Na2CO3 10H2O. Okay, Na2CO3 10H2O is the formula of the washing soda. So this is the hydrated washing soda. Okay, so just by heating the baking soda, we get the washing soda. Understand? You want to understand this about this concept. Okay, so baking soda is heated to get washing soda. What is the uses of baking powder or baking soda? Both are important. You have to understand. Okay, see, for making the baking powder, we use the baking soda, and baking soda is also used as a mild antacid. It is used as an ingredient, as an antacid, that because it's a base. And baking soda is also used in the soda acids and also the fire extinguishers. It is used in the soda acids and also the fire extinguishers. Very important, students, you want to note down. It's a very important concept. Okay, so you have to note down each and every concept here. Uses of baking soda, I am telling. Baking soda is used to make the baking powder. Okay, and it is also used as an antacid. What is antacid? Antacid is nothing but the base. Antacid is nothing but the base. Okay, yes, and it is also used in the soda acids and also the fire extinguishers. So ಇಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ ನಾನು ಏನು ಹೇಳಿದೆ ಇದು ನಿಮಗೆ ನೀವು ತಿಳ್ಕೊಳ್ಬೇಕು. ಏನು ತಿಳ್ಕೊಳ್ಬೇಕು? ಬೇಕಿಂಗ್ ಸೋಡಾ ಫಾರ್ಮುಲಾ ಏನು ತಿಳ್ಕೊಳ್ಬೇಕು. ಓಕೆ, ಹೌ ಇಸ್ ಬೇಕಿಂಗ್ ಸೋಡಾ ಫಾರ್ಮ್ಡ್ ಅನ್ನೋದನ್ನ ತುಂಬಾ ಕಡಿಮೆ ಕೇಳ್ತಾರೆ. ಬಟ್ ನೀವೇನ್ ತಿಳ್ಕೊಳ್ಬೇಕು, ಹೌ ವಾಷಿಂಗ್ ಸೋಡಾ ಈಸ್ ಫಾರ್ಮ್ಡ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಬೇಕಿಂಗ್ ಸೋಡಾ. ಪಬ್ಲಿಕ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ 2020 ನಲ್ಲಿ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್, ವಾಟ್ ಆರ್ ದ ಯೂಸಸ್ ಆಫ್ ಬೇಕಿಂಗ್ ಸೋಡಾ ಅನ್ನೋದನ್ನ ತಿಳ್ಕೊಳ್ಬೇಕು. ಓಕೆ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Now let us move for washing soda. Washing soda formula ಏನು? As I told you, Na2CO3 10H2O. Hydrated washing soda it is. See, how do we get washing soda? Recrystallization of sodium carbonate gives the washing soda. See, when we heat the, here I showed, when we heat the baking soda, we got Na2CO3. Correct? So, for this Na2CO3, when we add the water, 10 molecules of water, we get the Na2CO3 10H2O, that is the hydrated washing soda, because it contains 10 molecules of water in it. Understand? And the washing soda is a basic salt. Washing soda is a basic salt, my dear students. You want to note down. Washing soda is a basic salt. What are the uses of washing soda? It is used in the glass or soap or the paper industry. It is used to manufacture the borax. It is used as a cleansing agent for the domestic purposes, and it is also used for removing the permanent hardness of water. Very important point this is. Okay, washing soda is used to remove the permanent hardness of the water. Okay, very importantly you want to understand. Okay, in this point in the examination they will ask, how do you get washing soda? By using baking soda. Okay, and what are the uses of washing soda? These uses you have to write. Next, you have to understand about the plaster of Paris. Plaster of Paris is nothing but calcium sulfate hemihydrate. Formula CaSO4 half H2O. CaSO4 half H2O. Very important. See, on heating the gypsum, how do we get this POP? How do we get COP? See, when we heat the gypsum, formula of gypsum is CaSO4 2H2O. So gypsum formula is CaSO4 2H2O. When we heat the CaSO4, that is the CaSO4 2H2O, when we heat this, okay, at 273 Kelvin, see heating symbol at 273 Kelvin. When we heat the gypsum at 273 Kelvin, I think it is 373. So in the textbook, yeah, it is given 373, not 273. Small correction. Okay. When we heat the gypsum at 373 Kelvin, it loses the water. This gypsum will loses the water. As a result of it, it forms CaSO4. It forms CaSO4 half H2O. So this is what we will call it as POP, which is nothing but calcium sulfate hemihydrate. POP is nothing but calcium sulfate hemihydrate. Okay, now, so in exam they may ask you, how do you get the POP? So how do you get POP? By just heating the gypsum at 373 Kelvin, we get POP. What is the formula of gypsum? formula of gypsum is CaSO4 2H2O. When you heat this gypsum, it loses some amount of water. As a result of it, it produces the POP, that is CaSO4 half H2O. It is nothing but calcium sulfate hemihydrate. Okay? Yes. So, very important, you have to understand. So, you can also get the gypsum back, children. How do you get the gypsum back here? See, when we add the water to this again, when we add the water to POP again, we get the gypsum back. That is CaSO4 2H2O. Very important topic. Okay. And what is the uses of this POP? POP is used in the hospitals to support the fractured bones. It is used for making toys, materials for decoration. It is used for the surface to make the smooth. See, this is particularly they ask in the examination. Very important point. They ask in the examination. Next, water of crystallization. Last topic, this one, children. You have to understand, this is the water of crystallization. See, yakendre nimge moor ide. Nimma textbook nalli 3 they have given. 3 formulas based on the water of crystallization. So, all the 3 you want to understand. Okay. See, what is meant by water of crystallization? See, when we are adding some amount of water to the compound, so that water contains some amount of, the compound contains some amount of water in it. Okay. So, we say it as water of crystallization. So, I think you have come across this concept. It is in page number 32, children. So, water of crystallization is nothing but fixed number of water molecules in one formula unit of salt. For example, CuSO4. This copper sulfate contains some fixed amount of water molecules in it. That is CuSO4 5H2O. Okay. So, this is what we call it as water of crystallization. Water of crystallization is nothing but the fixed amount of or fixed number of water molecules present in one formula unit of that particular salt. Copper sulfate, now sodium carbonate, calcium sulfate, all these are salt. In these salts, there are fixed number of water molecules for one formula unit. So, it is called as, water of crystallization. I repeat once again, if you are asking to repeat. See, what I have to repeat, whether I have to repeat the crystallization part or the previous part, please mention. Okay, once again I say, water of crystallization is the fixed number of water molecules. For example, CuSO4. See, there are 5 fixed molecules of water. Sodium carbonate, it has 10 fixed molecules of water. Calcium sulfate, 2H2O, it has some fixed amount of fixed molecules of water. Okay. So, that is what we will call it as, water of crystallization. Okay. Very, very easy, children. And you should know only 3 are there. So, CuSO4 5H2O is there, copper sulfate, and Na2CO3 10H2O. I think you know that this is the washing soda. CaSO4 2H2O, this is the gypsum. Okay. Here only I have mentioned, you can observe how many amount of water molecules are present. At final, from this particular lesson, you will get 3 marks, 100%. 100% 3 marks per diagram. If you see the question paper, dear students, in most of the question paper, we have reaction of zinc with the dilute sulfuric acid, that particular diagram. Reaction of, zinc with the dilute sulfuric acid, which produces the hydrogen gas, pop sound test, okay. All these things, they ask in the examination. Very, very important thing you have to understand, dear students, the reaction of zinc with the dilute sulfuric acid. You want to practice this diagram for 3 marks. And don't ignore this also, action of, as it is acid solution in the water conducts electricity. If this diagram is asked, it will be asked for 2 marks. One then pitkoli. If they ask this, they don't ask this. If they ask this, they will ask different diagram from, from the chemistry, that is action of steam on metal keltare. Okay, na action of steam on metal keltare. Idana keldre action of steam on metal. Idana keldre, they don't ask this. Okay. Yes, very important. So, for this, we have completed today's crash course, children. So, the entire lesson in one crash course is, I think it's a very useful video for you, whatever I have explained in today's class. So, those who have understood the entire class, I request you all to please drop your valuable feedback once the live is completed in the comment area. Okay, please put your valuable feedback in the comment area. I told you about the dock plant already. Dock plant is a plant which contains the basic properties in it. Understand? It contains the basic properties in it. So it is, it makes the, area to get neutralized. It makes the area to get neutralized, children. Okay. So that is the one thing I can say that is easily you can understand. So related to biology, I have already explained it everything. I'm explaining about balancing the equation. So what I can do is today evening for everyone who have doubt in balancing the equation, okay, let me take on 20 minutes live class. So I will give some certain equations that how to balance. So we will conduct. Now it's already time. It's already 7:41. I think you all have to go to school. But if you are having the leave, then please use your time for studies. Even I have to leave the class now because I have to move for the school. So if you are asking about Zen papers, yes, Zen papers are very, very important, dear students, because it gives an extra boosting dosage for you to prepare for your examination. It is not that same questions will come. It is that the questions are very unique, and if you solve that question, it is easy for you. And if any of you are here in the live class today, if you are having the Zen papers, please share in the Telegram group. Okay, it will be very helpful for me so that I can explain for many students also. Okay, yes, that's all for today's class, children. I hope you all have understood, and it was a very productive session today. So whatever I thought today, okay, I'll share in it at Telegram. Please, in yesterday's file I'll share now. So please go through it, study, use your maximum time for the studies purpose. All the best for you. Don't waste your time, and a happy day ahead. See you all in the next crash course for the day 14 for the frequently asked questions from the acids, bases and salts lesson, and also the most expected questions in the exam. Okay, yes, thank you so much, children. Have a nice day. See you. Bye bye. So evening timing you're asking? No, yes, evening timing, I think I will be free only after 9. After 9 I can start. I will anyhow I will update in the community section. Okay, fine. Thank you so much, children. Take care. Bye bye.